All right, well, I'm excited. We are going to be looking at Article 680. Now, many of you listened to some of the videos and podcasts that I've done before in our series, and you know that I've talked about Article 680 and that I serve on Code Making Panel 17. But what we wanted to do was an in-depth study of Article 680 and kind of cover some of the topic areas that people are confused about or give our opinions on it. And with me today, I have a special guest from Siemens, and it's Vince Delacroix.
Yep.
And he's with us today, and we're going to be covering, and he also tell you a little bit, Vince will tell you a little bit about himself. Vince, tell our viewers a little bit about yourself and what you do with Siemens.
Yeah, well, first, thanks, Paul. Thanks for the invitation to visit Electrician Live headquarters, world headquarters, I should say, and review the material. So, yeah, quickly, my role at Siemens sort of two-part. One is business development manager, where I support the electrical inspector and installer community from a codes and standards perspective. And I do a lot of that through the IAEI, International Association of Electrical Inspectors, attending a lot of chapter meetings and local meetings. And the kind of part two of my role is part of and being part of our codes and standards team. So there's 6 of us on the Siemens Codes and Standards team, which enables me to participate in what we see on the screen, different code making panel, as well as other NFPA technical committees and UL standards technical panels. So recently appointed to code making panel 17, and panel 17, as you know, Paul, has Article 680 swimming pools under its purview, as well as NFPA 73, NFPA 99, healthcare facilities. I was recently appointed to that technical committee also, so that'll be an interesting one. 1078 is actually a very, very new standard that NFPA published just about a year ago about electrical inspector professional qualifications. So that was unique to be involved with that brand new standard from its infancy. And I came up in the trade like you did, Paul, as an electrician, licensed in Florida as a master electrician, as well as the state of Washington. Had my own contracting business in Florida for about 8 years before becoming an inspector and a plans examiner. So I'm licensed in Florida as a electrical inspector and plans examiner, and I did spend about 11 and a half, almost 12 years as a AHJ for a city where I live in Florida. And again, I do have ties with the IAEI, so I am the Florida Chapter Education Chair, and I also support the Southern Section members as Assistant Secretary Treasurer.
Yeah, and I think I've come down to the Florida chapter quite a few times and done some training and presentations and working with your chapter. And also, and those that don't know, IAEI is the International Association of Electrical Inspectors, and they're actually based right down the road here in Richardson, Texas. So right down the road, and they have inspectors that are part of that association that are all over the country. So absolutely. So thanks for joining me today. Definitely. So I do notice that we've done some specials on Electrician Live. I've done some shows on some Siemens products and things like that, but I understand you have some guides and things that are out you want to share with everybody. Again, they're going to be relevant. We're in the 2020 code, and we're recording this in June of 2020. So things change over time, but these documents are currently relevant for the 2020, as well as some new products that are out in 2020. You want to talk about that a little bit?
Yeah, so the 2 documents I have on we have on the screen, the one on the left is a first for Siemens. Really, my urging was to get Siemens to produce some sort of documentation to support the 2020 changes. So we came out with what we call an application guide, where our product managers and our codes and standards team highlight we've got about 24 changes in there, what we're calling significant changes in our eyes, where we provide the new language, the new 2020 language. We provide some commentary from our product managers and our codes and standards folks, and we also supply some pictures of Siemens-specific solutions to support the change. So that's a PDF document, very easily shared with everyone in the industry. It's free, there's no charge to anyone, and we're happy to get that out to industry for whoever wants it. or want to see it and read it. So that's out on the streets now, available through emailing me or finding me on LinkedIn, and I'm happy to share that with anybody. The document on the right is information about a new product that we just launched about 2 months ago, and that's a plug-on neutral load center. So it's a first for Siemens, plug-on neutral load center and all the associated breakers for it. Again, that's just documentation that I have. Anyone in industry who needs information on the plug-on neutral load center or wants more information on it, again, easily, electronically shared through email. I'd be happy to supply that to anybody also.
And now for those that are interested as well, we did an Electrician Live episode that aired in June here on these products, on the plug-on neutral, kind of get a more in-depth understanding of them. And it's quite interesting because as an electrician, we're so used to installing thermomagnetic breakers. It's just taking the ungrounded hot conductor to the breaker. And when you're dealing with AFCIs and GFCIs, you understand you have the pigtails. But their new design for them is ability to plug on that neutral, and you can just take your neutrals to the bus as normal, take your equipment grounds to the bus as normal, and everything's done through the breaker, and it interconnects with an integrated neutral bus. So nice design, gives you a lot of space in there. So again, check that out. Go watch our video that's available from Electrician Live to find out more about those products as well, or get with Vince as well. And we'll have that at the end of this series is information and contact information so that you can see about going ahead and getting some information on that. All right, Vince. Well, dealing with 680 is one of those articles in the code where people kind of just don't pay a lot of attention to. They might not do pulls, but every now and then. And the problem with that is you get kind of complacent, and you don't think about the hazards that are involved with doing things incorrectly in 680. So we're so busy immersed in things like 250 grounding and bonding. We're so immersed in branch circuits, 210, 230 for services, and we kind of lose sight of the structure of the code. Chapters 1 through 4 of the NEC apply broadly throughout the NEC. 5, 6, and 7 will modify or supplement chapters 1 through 7. And so we have to think about those things. And so when we get up into 680, we tend to do things a little different.
Yeah, so we have that information about how the code is laid out and how we maneuver through that in 90.4. And there's a nice little diagram about what pertains where. And 680 is built a little differently than a lot of other articles. We can see that we have the 8 parts up on the screen. And when I look at 680, I think it's really compartmentalized because we see the language after the parts that we included on the slide here. So example, we look at part 2, permanently installed pools, and in the scope, when we look at the scope at the beginning of that part, it tells us to comply with part 1 and part 2, meaning we're forced to stay inside parts 1 and parts 2 only when we're dealing with a permanently installed pool, and we don't have to drift to apply anything in part 3 or 4 or 5 or in any other parts. But if we scroll down to fountains in part 5, that scope says comply with parts 1 and part 5, but if you continue reading the scope, depending on exactly the type of fountain you're dealing with, you possibly may get kicked into parts 2 and parts 3. Yeah. So really, we have to look at this, compartmentalize it, and the biggest thing, I think, is to find out and be aware of what exactly our installers or AHJs dealing with in the field. Is it a permanently installed pool, or is it a storable pool,
right,
or is it a fountain, or is it a splash pad now in 2020? And we have that definition to make sure that we land in the right part and we don't drift out of those parts unless the scope inside the article actually allows us to do that.
Yeah, I agree. I think what people don't do a lot is they don't stop and read the scopes. There's been a lot of efforts for electricians in the past to do something and not really read the scope. And next thing you know, the article doesn't even apply to what they're dealing with. And so the one that impacts me the most here is obviously spas, hot tubs, immersion pools when it tells you it complies with Part 1 and Part 4. It's very specific, right, and you don't venture out into Part 2 or Part 1. I mean, you're venturing into Part 1, but you don't go into Part 2, you don't go into Part 3, you go to where it says to be, right, and you stay within that. So we're going to cover all that in this series. Again, it's going to be obviously an 8-part series. We're going to dig into each part of this and have an open discussion. There's some things that we could agree on, some things we may disagree on, but again, it will all be based really, the things that we might agree or disagree is application and intent, but the reality is the code is the code. So we'll look at the code, and again, that's the beautiful thing about the NEC. It is, again, black and white, but everybody could have a different interpretation. We just want to kind of keep everybody within the same realm of logical interpretation. So we're going to cover all of these, but again, I guess starting the first thing is like I always tell people, definitions. Yeah. You got to know the definitions. Again, people gloss over Article 100. They don't really pay attention to definitions that much, and then they go astray. Same thing happens here in 680. You really need to understand what a permanently installed pool, what is a storable pool, what is a fountain. You need to understand these definitions. So we're going to jump into that and kind of have a discussion. I encourage you to follow along as well in your code book, as we do as well. We've got our code books here, and we've got the code book online in case we need to reference that to have a little discussion on what the exact intent is of the words that are written on the screen. So, first definition we're dealing with is permanently installed swimming pool, wading, immersion, and therapeutic pools. So, under this definition in 680, it says it's constructed in the ground or partially in the ground. All others capable of holding water at a depth greater than 42 inches. And?
Yeah, all pools installed inside of a building. Then that's regardless of the water depth and even whether or not they're served by electrical circuits. So anything inside, basically, even if it has no electric, and even if it's only a few inches deep, would be considered a permanently installed pool. So that's important to note, although I can't see it. I've seen a tremendous amount of pools inside, other than inside, gyms, fitness centers, that type of occupancy. Mm-hmm. But the 42-inch measurement here is really critical. The greater than 42-inch depth, because we're going to compare that to the storable pool definition next, right, to discern the difference between a portable and a storable pool. And the 42 inches is going to come up again for storable pools. And so that's an important number to keep in the back of your mind, if it can hold water to a depth greater than 42 inches.
So here we see an example, and it shows the maximum water depth. Again, to me, the maximum water depth is a spillover point. So
yeah, and we have that definition in 680, maximum water depth, that we're going to look at in a few slides.
So in here, I see the image, whether you can see it or not. I believe the depth here is 48 inches.
Yeah.
So this is over 42.
Absolutely.
So again, permanent. May look very portable to many people. I mean, this might look like it's constructed up, sidewalls, everything is a componentry. You put it up, it has a liner, but it is greater depth than 42 inches.
Yeah, and this was, in my experience as an AHJ, and again, I'm in Florida, so we see a lot of pools, and I saw a lot of pools out in the field as an AHJ. This was probably the most troublesome from an installer and AHJ perspective about determining what this thing was. Was it a permanently installed pool? Was it a storable pool? And the break point is that 42 inches. So if this type of pool can hold water to a depth greater than 42, as we see in the picture for this one, this is 48. This is a permanently installed pool. But we can have the same pool made of the same material, holding water to a depth of less than 42. And it's going to be a storable pool, yeah, right? And it's just the water depth, not so much the construction of the pool or the material of the pool for the most part.
So the target area here for them to remember is, like you said, that 42 inches is going to be that line of demarcation on whether or not something's considered, even if they're made exactly the same.
Yep.
It's the depth of water.
Correct.
Of course, and we also remember, again, like I said, indoors, doesn't matter.
Right.
Okay, it doesn't matter the depth; it's still considered permanent salt pool.
Mm-hmm.
All right.
And we say for the most part, because we're going to see a little blurb here when we're looking at storable pool now.
Okay, so go and pick this one up and.
Okay. So we shift over a thought process a little bit to the storable swimming pool or immersion pool, spas or hot tubs.
All of the storable type.
Correct.
Right.
Right. So the definition tells us it's intended to be stored when not in use, meaning the thought process is when it's not in use, this is going to be drained and put away. These can be constructed on or above the ground, capable of holding water to a maximum depth of 42 inches. Like we spoke about, maximum 42. Or it could be the pool, spa, or hot tub constructed on or above the ground with non-metallic molded polymeric walls or the inflatable fabric walls, regardless of the dimension. So if they basically...
Soft spas. I've seen those soft spas,
right.
and that would be an example of a storable. I'd also remind people out there that listen that say, hey, my pool is storable, but I don't intend to store it. It stays up all the time. It's irrelevant what you intend to do with it. It's the concept that it is designed to be storable. Just because you want to leave it up all the time, it still would be a storable, again, if it's capable of holding water to a maximum depth of 42 inches. So, again, whether you remove it or not, it's irrelevant to this,
right.
That type of thing.
But the truly inflatable fabric walls ones can be at a depth greater than 42.
So even though they may appear to be storable, they
right.
can hold the water greater than 42, then they're permanent.
Well, the definition is telling us in the last bullet point, if they are truly the inflatable or polymeric walls one, regardless of the dimension. So to me, that leads me to believe it could be any depth.
As long as it's a non-metallic molded polymeric
Correct.
wall or inflatable.
Correct.
Reason I point that out, and Vince picked up very well on that, is the fact that the wall construction, as they start getting deeper, the limitations of polymeric wall or the fabric type of walls is going to limit the depth inherently in the amount of water. It could be deeper, but there is going to be a limitation there at some point with that thickness.
Yeah, so there's a little caveat there, and these definitions I don't think are easy to maneuver through. You really have to read them slowly, take them one at a time to determine what it is that you have out in the field. And I think I checked yesterday. I quickly skimmed the definitions. There's at least 14 definitions associated with pools, spas, hot tubs, whether they're storable, permanently installed or not. So it really does take some maneuvering through them because there is some subtle differences in the language that we'll see to determine what it is that the product out there actually is and where it falls in 680.
Definitely. All right, so this is, again, kind of like that picture that we saw earlier. So this is kind of just hammering home visually that this pool could be storable or permanently installed depending on the depth of the water.
Right.
So bear that in mind because, again, you might think you're getting something that's storable and it's 48 inches and you install it and you have an inspector come out and they consider it permanent and you're thinking, no way, this is storable. But the depth is going to say differently.
Right, which is, there's significant requirements associated with a permanently installed pool
versus
that
storable.
Are not associated with the storable pool.
Right.
So, yeah, it's important to determine what it is again.
And so, Vince, talk to us a little bit about this. Obviously, we have pump motors for permanently installed as well as storable. And the question comes up a lot, and I'll let you explain this, because I also believe that you have a previous history also with listings or where you did something with the kind of a
field evaluation
type of things.
Right.
So, but for people out there, pool pump motors that are permanent. Can you use the permanent ones on a storable? Can you use a storable on a permanent? So I guess that's kind of a lead into what we're talking about here with this slide.
Yeah, I think the answer is no. I think
The short answer,
this
the
is
quick answer.
Yeah, it's a one-way street for these pump motors, and we can see the language on there. It's pretty big. We see the caution. This pump is for use with permanently installed pools only.
Right.
Don't use it for storable pools. So has a specific listing.
Now we can hope that all pumps say that. It's listed, but we can hope that this language. I don't know, and I don't know 3184. But is that language in there required to say caution? This is for use only with this, with it permanently installed. I would hope that's some language in there that just this manufacturer didn't add it.
I assume, again, I didn't read 3184, 31B4, and I'm not sure what that
I don't know if it's
what
a
that
B
says.
or a,
but I would think that standard requires that marking on it. But that's a guess on my part.
But I'm pretty sure it probably would, because there's limitations with the pool pump motors that are direct wired application,
right?
Versus what you would get for these little, these, I could say little, these storable pools and things like that. So I think we also, being this is permanently and this has the everything written on it, we do have an example here.
Right. So this would be storable pool. I think it says it down at the bottom under the caution marking. Second sentence, it says this pump is for use with storable above ground pools only. Do not use with a permanently installed pool. So these are not interchangeable just because it's some type of pool pump motor. If you're dealing with a storable pool, it has to be a pump specifically listed for the storable pool. If we're dealing with a permanently installed pool, then the pump has to be specifically listed for the permanently installed pool.
The moral of the story: look at your listings.
Yeah.
Check the motor.
Yeah, and I saw the blurb on this pump also. We should point this out too, that we just read on the bottom. This pump is for use with storable above ground pools only. Looking inside 680, there is no definition of an above ground pool.
Okay.
There's no, I don't want to say
Well, we
there's
have to
no,
use common sense. Above ground, right?
there are permanently installed pools that can sit above ground or partially in the ground.
Mm-hmm.
But as far as a definition for an above ground pool, there is none.
Well, you know what they say, Vince. Welcome to Code Panel 17. So, again, that reminds you, if there is something that you don't agree with in the National Electrical Code, you have the ability to speak your mind or forever hold your peace. We are currently in the public the public input stage, so you still have the ability to send in it. Remember, don't send in stuff that's not substantiated or just because you don't like something. We're going to file that at the round filing cabinet at the end of the table, and that's called the trash, because you need to substantiate any public inputs in order to generate public comments on those public inputs, and then we make the code better. But you can be involved, so don't sit back and say, I just don't like something or I disagree with it. You got to be involved in it. And that's what I'm involved in the code development process. Vince is involved with it as well. And you can be involved because anybody can do it. Get a free account from nfpa.org and you can submit public inputs, public comments, and things like that. But be sure that you research what you're submitting so that it makes sense, and explain it as best as you can to the code making panel so that we can give it the best opportunity to potentially make it in the code if it makes sense. That type of thing. Next, definitions of fountains. So you wanna lead this one off, Vince? Says again, I think there's different conceptions, misconceptions, I should say, of fountains. What a fountain is, like what you might see ornamentals versus some other. So kind of work us through this definition.
Yeah, so I try to make it easy and I broke all the definitions down into the bullet points to make it hopefully a little easier to maneuver through as we review the material. So
yeah, because in the code it's just one rambling. It's not itemized. It's not it's not in a list item. It just kind of rolls.
Right. So now, fountain, specific to a fountain ornamental structure or recreational water feature. One or more jets or streams of water are discharged into the air. This broad fountain definition It includes a splash pad, although it's interesting that we have another definition for a splash pad.
Which is new for the
Which is new.
2020. We had quite a good debate last time on splash pads and whether they were to be considered a fountain or not. But we have a definition for splash pad. But you're right, it defines splash pad, but it's also here under fountains to kind of it's here. So
it also includes the ornamental pools, which I don't think we have a separate definition for that in 680. A display pool and a reflection pool. So those are all captured under this fountain broad definition. But it does not include something like a drinking water fountain or a water cooler. That's not what we're dealing with here in 680. A drinking water fountain or a water cooler, those would fall under 422, most likely Article 422 for appliances.
Okay. Which is also under the purview of Code Making Panel 17 as well. Right. So there should be some synergy between what the work we do in this article versus what we would do in 422. Right. One of the things that did change with this was to clarify fountains, because again, we kind of made a change to differentiate water fountains or water coolers, because again, the drinking fountains is totally different thing. So clarified that in the 2020 code. Now, permanently installed decorative fountains and reflection pools. Okay, so again, we had just now fountains, and so now we have different fountains. There are permanently installed decorative fountains and reflection pools. Interesting enough, and we'll probably cover this, that you can have these decorative fountains and reflection pools that are so closely related to a swimming pool aspect that could actually turn the fountain into having to meet the requirements of a permanently installed pool.
That's right.
So, I mean, you know, now in this case, in the image we see here, this is obviously not for anything that's going to do with a permanent pool. It's separate. It's a decorative fountain application, so it's got its own definition. So you want to take that off, and we'll.
Yeah. So they're constructed in the ground, on the ground, or in a building in such a manner that the fountain cannot be readily disassembled for storage, and whether or not it's served by electrical circuits.
Certainly not portable. This storable.
Right. The definition also tells us they're primarily constructed for their aesthetic value. They're not intended for swimming or wading. So nobody's really supposed to be jumping in these things to float around. But
we know they do.
People do.
And so to me, that's also a lot of the aspects of whether or not this electricity is served to it or not. Mm-hmm. There's still associated hazards that can be involved in it. So.
Right. If you go on the YouTube, and I'm sure everybody does, you can find people staring at their phones and texting and walking inside malls. And then they fall right into the fountains that are inside the malls.
I have seen that. I am not going to say whether I've ever done that. I have not, but I've seen it. Mm-hmm. Immersion pools. Okay, so immersion pool is, again, I had to coin a phrase, whether or not you're, whatever religion you're in, but sometimes we refer to them as baptismal pools. Basically ritual immersion. And, okay, so we have the definition of immersion pool. A pool for ceremonial or ritual immersion of users, designed and intended to have its contents drained or discharged. Obviously, you have lots of people, random people, at different times going into this, and again, they will drain it, refill it, drain it, refill it. It's not designed to stay full all the time, that type of thing. So, anything else you want to add on that? That's pretty cut and dry.
It is. I guess the only other thing to note that this is a new definition for the 2020. We didn't have this previously.
So what did we call it? We probably call it a pool.
Yeah, great.
I mean, we probably call it a permanently installed pool. The depth, if it's in a building, we know it's permanent. If it's in a church, it's permanent. So what else were we going to do? So I think that might have caused problems for some people with how you have to, some of the requirements for the equipotential bonding and things like that. You didn't know.
What did we do before? Did we treat it as a storable pool? Was it treated as a hydromassage tub or some type of physical therapy spa? Yeah. And the question is, I don't know. We probably get, if we asked 50 different AHAs and 50 different municipalities, we probably get 50 different answers.
Great example of an interpretation. Somebody having to interpret it because there's no guidance. So that's a great example of why the code changes. So people ask all the time, do you guys on code panels and everybody just sit around and can't think of things to do and you want to create code and the book's getting thicker and all that type of stuff? No, we learn every cycle. I mean, you can't get it right. And all of the code panels don't all talk together. You know, we do our own thing, and you have liaisons that carry stuff from panel to panel and different things like that. But things get left out. And we learn as we get more understanding and more code experts, like Vince, will come to the meetings and be part of the committees. And we learn all these things. And again, we realized that we didn't know how to deal with what an immersion pool was. And so we had to have a definition now.
Yeah, I mean, everybody has to realize if you're a user of the code, and I know it's frustrating sometimes, firstly, certainly frustrating from an installer standpoint on some instances, or AHJ standpoint or a design standpoint, that the code is a living, breathing document. It'll never be perfect.
No.
There's a lot of time spent by panel members to try and craft perfect language, but the reality of it is, installations in Florida compared to Texas, compared to Alaska, are a little different, and it's really difficult to craft the perfect language and get it right consistently. Certainly try, absolutely. So we certainly try to do that, and we do that with help from the public to initiate change. So it's really important for industry, anyone in the industry, to be involved. And if you're not involved in the change process, in my opinion, you really don't have.
You don't have any say.
You don't have the right to moan and groan afterwards.
Just do it.
If you're not involved in trying to change or make it better.
Yeah, and if people say, why is the code written a certain way? It's, again, like you said, it has to cover a broad reach, from the East Coast to West Coast, from the North to the South. And every area is different. Climates are different, applications are, so they have to have it. So it's written in a way that it can be utilized in that fashion. So, again, I've loved being a part of the code development process rather than, sitting on the sidelines. Be active, involved in it. And it takes a serious level of commitment, but it's very rewarding to see the code get better each cycle. And I don't know about you, but I think 2020 was a huge leap forward, and I'm excited 2023 I think will be as well. This a lot of people getting involved.
Yeah, a lot of changes in the 2020 in 680 and outside of 680. So yeah, another active code cycle of the year for change.
Okay. Next definition is spa or hot tub. I will tell you right up front, it's so important to understand definitions because so many people see the jacuzzis and they're hydromassage bathtubs, and they want to call them spas and hot tubs. So we have to have definitions to distinctively what a spa and a hot tub is. So we have this definition here, and I'll let you kick it off and describe this a little bit, and I'll chime in.
Okay, so let's run through it. So it's a hydromassage pool, a tub, recreational or therapeutic use, not in a healthcare facility though. These are outside the healthcare facility world. All right. I think it's pretty obvious they're designed for immersion of users, of people. They usually have a filter or a heater or some type of blower. They do have something that's circulating the water or heating the water. They can go indoors or outdoors, on the ground, in the ground, with a supporting structure. That will really be driven by its listing, most likely, on where these things could go. And they're generally not designed to have their contents drained or discharged after each use.
Which is a significant difference from a hydromassage bathtub.
Correct.
Which gets drained after every use.
Yeah, so
you kick chemicals and you do, whether it's ozone treatments that you do. Now, this hot tub that I used to have was ozone, and that was its process of sanitation. But you have the chemicals, whatever, so you're not going to drain the water. So distinctive difference.
Yeah.
A company like Jacuzzi, for example, might make these standalone hot tubs and spas, but they also make the hydromassage bathtubs as well. So just because they're made by the same manufacturer does not mean that one is a spa and hot tub and the other is as well. So
so again, it's really important, like you said, to be able to maneuver through the definitions. And when in doubt, when looking at these, look at the listing marks and the information from the manufacturer, which will hopefully give you guidance on what it actually is. Is it a spa? Is it a fountain? Is it a storable pool? Is it a permanently installed pool?
Takes you back to definitions.
Yeah.
You just got to know them. So the next thing is, we just talked spa and hot tubs, but we also now need to know that, like what I had a self-contained. Now you have the type that can actually go in the decking, go in the ground, like you said, but you also have the self-contained, which is everything is contained. The blower motors, the heating, the circulation, the controls, everything is self-contained in a factory design type of system, right? So it's factory fabricated unit, consists of a spa or hot tub vessel with all the water circulating, the heating, the control equipment is all integral to the unit. And of course, ours had the ozone filtration system built into it and everything. In fact, ours also had a stereo system built into it, so that when you're in the water, it actually played music from the water through the bubbles, and you could hear it while you were laying in it, because anything else, the speakers would be so loud. But it was designed so that with your head on the rest, you could hear the music better. And so that was kind of a neat the way it would do that. But it's equipped, again, it can include pumps, air blowers, heaters, controllers, again, sanitizing generators like the ozone, that thing, all incorporated in it. It's factory, and it's usually, wired externally to a system, whether it's hardwired, and some of them you can actually even get, cord and plug for those applications.
So, just be aware, because we're going to see a little bit different language and some other definitions. This self-contained spa or hot tub, they use the language integral to the unit. And we're going to see language in a different definition, and maybe the next one, where it talks about the equipment being on a common base. So there's a subtlety there of the equipment being integral to the unit compared to mounted on a common base.
So at a remote location. Because so these are integral, and maybe that's will give us an opportunity to look at the code, to see it, so we can identify it, because we want you to be able to see it in order to understand those subtle differences.
Yeah, and again, I think whether it's integral to the unit, like we have here, or what we'll see on a common base later, I think, again, if something is in question as to exactly what it is, I think it's going to drop back to the listing. That's going to help us determine what exactly we're looking at and dealing with from an installer or AHA perspective.
Okay.
Yeah, and I think this is a good example. The packaged therapeutic tub or hydrotherapeutic tank equipment assembly, which is pretty long. But anyway, again, it's factory fabricated, but here's the tweak in the language, consists of a spa or hot tub vessel with all the water circulating, heating, and control equipment mounted on a common base, not integral to the unit. So these supporting circulation equipment is mounted on a common base. And again, it can be the pumps and the blowers and the lights and the sanitizers, but it's not built integral to the tub. It's mounted on some common base.
A common base that's in addition to the vessel.
So that's the best pictures I could find. I can never find the exact pictures that I'm hoping to when I do my searching on Google Images, but I think this does it. We have, especially on the bottom, where these vessels or tubs, this equipment associated with it is mounted on a common base. A lot of times, some of the stuff just hangs off the side, and then can be removed. But it's not built integral to the unit. So little subtle differences between.
So it might be this scenario, whereas the fabricated, hot spa and hot tub comes with everything integral. It's built into it. It comes in a complete system. This, you probably have a vessel, and you have additional components of common base that will connect onto it, overhang it, or connect. That type of thing. All right. Hydromassage bathtubs. Again, wish I had one in my home that I have now. I do not. I had one prior to moving to Texas, and it was hydromassage bathtub, permanently installed bathtub. Okay.
Permanently installed, yes.
Equipped with recirculating piping systems, pump, and associated equipment, not typically having anything to do with heat. Usually it's the water that's part of the plumbing system. I don't know that it excludes that, but I've never seen any hydromassage bathtubs with a heating component built into it. I haven't. So...
Yeah, I'm trying to search my memory banks. I don't remember seeing them with heat either, now that you said that.
Usually because we drain them, and you're going to reheat it, refill it with warm
and fill
water.
it with hot water.
With hot water.
Yeah.
So, but it's designed so as to accept, circulate, and discharge water upon each use. Obviously, in this case right here, again, pull the drain, refill it. Right. It is a bathtub. And I think I have to explain that to people all the time. It has all these features. It's a bathtub. It's still a bathtub. It's for bathing. You can enjoy it. You can relax in it. It's for therapy, hydromassage, but it's a bathtub, right? Not to be confused with a hot tub or spa. Correct.
Yeah, and again, we would drift into a part of 680 that we wouldn't want to be if we considered this a spa or a hot tub.
Right.
The Hydromassage Bathtub has its own part inside 680, and I
get the luxury of staying in there.
Correct.
I don't have to do some of the things that I would do if I treated it as something else.
Right.
And of course, we're going to cover all that in this series. So you're going to learn all of that. But again, you're starting to see that the definitions are important, because if you go astray, you could venture into an area where it's good. Maybe it's going to make you do things that you don't need to do. It's going to cost more for the installation. The customer's going to have to pay more unneedingly. And again, I always tell people, even with grounding and bonding and everything, you can go too far. You do what you need to do. You can go too far and turn something which would have been a safe installation into a hazardous installation because you don't have a clue.
Yeah, and the reality of it is, I don't think any installer out there, certainly, I put my contractor hat back on. I don't really want to do something out in the field that the code doesn't require me to do. I want to meet the code requirements, absolutely, for the installation to be code compliant and safe, but I don't really... Why would I want to, unless I was really feeling flush or,
wanted just to give some
wanted
stuff
to drive some type of change order out, but I just want to apply what the code is telling me to what I'm doing, comply with the code, it's safe, installation, be done, move on to the next thing. Yeah. Now, we can always certainly go above and beyond.
Yeah, it's a minimum standard. We can, but we do, like you said, we have to be careful. Because when I teach grounding and bonding, I'm on Code Panel 5, and teaching grounding and bonding, people can go to the point where the minimum standard sometimes for grounding and bonding is there for a reason. If you go to beyond that and you go too far, you can create a hazardous condition, creating objectionable currents, other things that you think you're bonding stuff together. You think you're doing a better job, and you end up not doing a better job. Right. So again, that can go the same way here in when you're dealing with hydromassage bathtubs as well. So
yeah, I don't think anybody wants to put a equipotential bond around a hydromassage tub. I mean, you could if you want to, but really no requirement.
Come on, man. All right, this is new. It was very spirited in Code Panel 17 with incorporating these into it. A lot of people that knew a lot about splash pads came and talked about it. So Vince, you can lead us on this. I don't think that I've played on any of these anytime soon, and they certainly weren't around when we were younger. So what are these?
Yeah, but they have been around for quite a few years. So I guess that means we're old.
That's true.
But certainly for the last 15, 20 years, we've seen these around here, there, and everywhere.
Amusement parks like King's Dominions, Busch Gardens, Disney. They had the water parks. Probably had these things well before anybody took them into consideration of what they were. It's water. And sometimes they have lighting components or things near it, and receptacles, and so I guess it's things we have to think about. Yeah.
So this, when I started reading this, when it got incorporated into the 2020, I kind of breezed through it. I was happy that we had a definition for a splash pad, but looking deeper at this is to me, it's a really interesting definition now, because when we looked at the definition for a fountain, it said it included a splash pad, which was, okay, so that's interesting. Right. But now I look at the definition and it says a fountain with a pool depth. So now it's a fountain.
It's a fountain and a pool.
And the pool is mentioned in there, which is kind of interesting.
Great opportunity for public input, folks. If you want to get involved in it and help out, you can do that.
So Okay, we have to go with that. So it's a fountain, but it has a pool depth 1 inch or less, intended for recreation use by pedestrians. So 1 inch break point. That's interesting. But typically, these things are really not holding water. They're porous on the bottom and they're pitched, so water is draining pretty quickly out of them. So that shouldn't be an issue, hopefully. Does not include the showers intended for the rinsing prior to the use of a pool, spa, or other water feature, even though this isn't a pool.
It isn't a pool.
It's a splash
But it is
pad.
less than
That's a
42
fountain.
inches, but it's
Definitely
certainly
less.
not storable.
Correct. So it doesn't include these, preliminary shower areas outside of it that you may have associated with a pool where they require you to bathe before you get in and after you get out.
Interesting enough, fountains don't have a depth requirement either.
That's true.
So again, a lot of things mixing up in here with fountains.
So basically, this is a fountain with a pool depth 1 inch or less.
Yeah, there you go. I'm smelling a public input here. Still got time.
And I do have about probably 5 or 6 PIs in for the 2023 for 680, but I don't think I touched splash pad. So yeah, maybe
Needs a little work.
maybe I'll put something together. Right?
There you go.
We'll see. Or maybe it's going to be one of your listeners, which would be even better.
There you
who
go.
hasn't submitted a public input ever. We'll take this and grab it and say, well, this really needs to be massaged.
Well, I'm going to tell you, it's funny because just because you think we're on a code panel 17, it does not always foster change because we're on a committee, because people say, well, you're on a committee, you're pushing it forward. It's so much better if we have the public submit something so that we can all have an unbiased debate about it, and see if what you submit has warrant. And so again, I encourage anybody that looks at this and says we need to clarify exactly how we talked about it, send it in. You still have time. I think they have until the end of June, isn't it? I can't remember the exact date.
Actually, I think it's September. I believe it's the first week of September. Yeah.
You want to get it in because we start working on the code in January next year. We'll start coming back together, hopefully if the COVID-19 thing is all cleared up, and we can, and if anybody's asking, we're not practicing social distancing, but don't worry. Electrical Code Academy tested vents prior to this, so its temperatures are great, so we're good to go. All right. Okay.
This is all you.
Let's say we spent a lot of work in the last 2 cycles trying to define what a corrosive environment is. And I'm going to do my best to keep my opinion out of it because we worked very hard at trying to clarify. The problem I originally had, and here goes the opinion, is that we don't really define what a corrosive environment is. We give some guidance and we have some assumptions of what's considered a corrosive environment based on data or incidents that people can report, corroded material, metal. I will remind you that even if you look at this picture in this graphic, this is considered a corrosive environment by the code. Everything in there is plastic. So it would lead me to believe that a PVC type of plastic material would be very resistant to corrosive effects, and it is. Pool liners are a PVC type of material, and it gets contact with chlorinated water all the time. So I'll leave that part there and just read the definition, and then we'll comment on the definition.
All right, so I'll lead in to you leading into the definition.
Okay,
to say that, right, this language for the 2020 was in 68014.
Yes.
And has been relocated
We're
as a definition now.
Yeah, we'll leave the wiring methods separate.
Right, so we'll get to those. So for those who are just seeing this definition for the first time, maybe we can say, quote unquote, it's a new definition, but it's really, this language was in 68014 in the 17 NEC. Now it was plucked out of there and actually brought up as a definition.
Yeah, and the reason for that obviously is style, manual of style, and concepts. Again, we're describing something in a code requirement, and it's needs to be utilized. So we're moving it over into the .2 area of 680 because again, it's a definition. It's very much germane specifically to the 680, but it really needed to be separated and let section 14 deal with the wiring types that can be in those areas as well. So what the code says is areas where pool sanitation chemicals are stored, handled, or dispensed and confined areas under decks adjacent to such areas, as well as areas with circulating pumps, automatic chlorinators, filters, open areas under decks adjacent to or butting the pool structure, and similar locations. And of course, with that, we got an informational note, which is, again, not a mandatory requirement, but is giving some good information. I love informational notes. Again, the National Electrical Code is not an installation design manual, but the more informational notes at strategic locations can give the user some guidance and some road maps, I like to say, through the NEC. Good informational material. Certainly nothing that an inspector or anybody can hang their hat on. It's informational only, unlike a note to tables, which is very much germane to the table or other references. So what it says in the informational note, it says sanitation chemicals and pool water are considered to pose a risk of corrosion due to the presence of oxidizers. Example of that: calcium hydrochlorite, sodium hypochlorite, bromine, chlorinated, isocinicurates. Sinicurates, is that right? What I'm saying? You know something's got to be hazardous if you can't even pronounce the thing. Okay? So this is, goes on to say, and chlorinating agents that release chlorine from when dissolved in water. Now, soapbox. I don't even have a button for soapbox moment. We're swimming in all this. Your body's in this. Your pool liner's in this. Your plumbing systems are all in this. Now, the thing about bromine is bromine deteriorates very quickly. That's why you have to add so much to it. So again, initially charged with bromine is quite high concentrates, but then again, it goes off pretty quickly. Chlorinated water is usually anywhere between 11 to 13% chlorine. So it's a very small amount, but it's chlorinated water. It's not to say that that around pools we don't have a corrosive environment. But again, a lot of times we have to be very careful, because if you say something is a corrosive environment, you also wonder, is it very hazardous to us? And so you really have to draw the distinct line. What I would have liked to see, again, my soapbox here, Vince, and you can chime in and agree with me, is when I have a combustible dust environment, I give you microns. I give you the value. My problem with this is, if you're going to label something as a corrosive environment, to what level is it? Mm-hmm. What is the concentrations in the air? Obviously, this can be studied and tested. You're not going to do that. Inspectors aren't going to test that. But again, labeling it broadly as a corrosive environment in some areas, again, if you have a pool room where you store your chemicals and everything in there and it's in containers, what are you breathing in? You're going in it. So, again, we have to be very careful. But again, in all fairness to our panel, in all fairness to the development of this definition, it's very broad, and it's talking about conditions that could be considered corrosive, and it gives the leeway for the AHJ to make a determination, whether something's corrosive or not.
Yeah, I agree. It seems to be broad, but I think the concern, and you were in on the discussions, Paul. For the last few cycles, I'm just coming on to panel 17 now, so I don't have a lot of the background information on this. I didn't go look at the previous PIs and supporting information.
Some very spirited debates over this.
I'm sure I was in the room for some of the discussions along the way over the last cycle or two. But yeah, it seems to be broad, but I think the concern is what happens over time in these areas. Not so much the short period of time when it's first installed, or even the short period of time that people are exposed to this in the pool for an hour or two or three. It's what happens over months and years of the equipment being exposed to chemicals in the air around it.
Which again, before I change off this slide, I just remind everybody that all of that stuff that's in that room right there is plastic. Mm-hmm. Just think about that. All right, we'll go on to the next one. I didn't soapbox too bad.
No, that wasn't too
bad. All right, not too bad. Okay. Next, Vince, take this up. Again, we're all familiar with our lighting around our pools and things like that. We have this concept of, before you do this, I do have people that ask me all the time. They go, is 1,000 volts low voltage? And the answer is yes. Is 120 volts low voltage? Yes. Is 70 volts, is that low voltage? Yes. So over 2,000 is medium voltage. Over 35,000 is high voltage. Anything that is 0 to 2,000 is considered low voltage. So in order to clarify certain applications around pools and things like that to a voltage level, we had to have a definition. This is not new. It just was talked about other areas in 680 that gets moved over into a definition. What are we talking about? Low voltage contact limit. It's so important that they didn't just say low voltage. It's low voltage contact limit values. And we've got different types of little landscaping luminaires or pool-related luminaires that are going to have a low voltage contact level. So kind of what do we got here as for options?
Right. So, yeah, this is not a new definition for the 2020. I think this came maybe 3 cycles ago, 4 cycles ago.
Probably think 3 or 4 that it actually was in the code when you're dealing with luminaires and applications, and now it got moved a couple cycles ago over to here. Obviously, it broadly used. So
yeah, so it's basically, I think that what we would deal with the most, or most installers would deal with, would be the 15 volts, not exceeding the 15 volts AC, basically. We have some other voltage for DC. I don't think they come into play that much around the pools, but it's basically that 15 volt threshold. As long as we don't breach that 15 volt threshold, we're under the low voltage contact limit. And I think that holds true. You know, when we get into pool light transformers, we'll be looking at that, but a listed pool light transformer maxes out, and they usually have multi-taps on the low voltage side. They max out at either 14 or 15 volts.
And they're going to be listed for that application. Absolutely. They're going to be very aware of these low voltage contact limits. The manufacturers are sharp on this. They know. They know about it, what they're dealing with. But you have other options here. But at the end of the day, I think it's important to say, look at your equipment. Don't just go randomly grabbing something, install it, and not knowing if it's going to be in these areas. Obviously, you're dealing with anything that's going to be remotely around swimming pools and things like that. Then you need to know about the equipment. You need to look at the listings. Definitely need to follow that.
Yeah, swimming pools, 680, stuff, we'll say. Stuff is a nice technical word that kind of captures the pools, the hot tubs, the spas, the fountains. They're special animals. We treat them a little differently than we do in chapters 1 through 4 items. So we deal with them a little differently in 680, especially.
Okay, we had a little discussion. We were talking about all the different pools and things, but then again, a lot of the references talk about maximum water levels. What is the maximum water level? The thing that comes to mind, Vince, is if I have a pool with a skimmer and the water can never get above the skimmer because it constantly will pull the water out and circulate it, where's the maximum water level? And so is that the maximum water level? Or if I have an application where I don't have those and the water could get to the top and flow out, well, what if the skimmer's not working? What if that stops, which is doable? It can be clogged up. If you ever had a pool and you know that you don't do proper pool maintenance, it can fill up, and then again, it's useless and it's going to continue to fill. So we had to have a definition. So kind of talk us through this definition. We see the graphic. We're showing a pool and it's coping around the pool.
Right. So I think this one is a pretty easy one, actually, myself. The highest level that the water can reach before it spills out. And water does not spill out of a skimmer, in your example.
Yeah.
So it's going to be the top rim of maybe a permanently installed pool that we looked at really earlier in the slides that happens to sit above ground, that holds water to a depth greater than 42 inches. That very top rail would be your maximum water level. On this picture we're looking at, this is a permanently installed pool flush with the ground, but that, as you said, is the top coping. That is where the water is going to spill out. That's the maximum water level. And that a lot of requirements in 680 speak about the maximum water level, but not all of them. There are some references in 680 that say from the normal water level. There's not a lot, but there's a handful. The normal water level, I would consider the center line of the skimmer. That's where we normally fill the pool up to, and we stop filling it there, and that's kind of the level that holds true. But this maximum water level is going to be wherever that water spills out. And you made a comment about the skimmer filling up or whatnot. I can tell you from my experience in Florida, when those pesky hurricanes roll through, that, it can't discharge all that water quick enough.
Right.
And that water is spilling out over that coping on the permanently installed pool on a regular basis in hurricane season.
Right. So you have twice the input than what you can have the output, and it just starts to fill up, and it's got to go somewhere.
Yeah, and it's going to spill out.
All right. So that was our definitions, and I encourage you. And again, I think let's say we didn't cover them all. Understanding wet niche luminaires and definitions of a wet niche luminaire, understanding what a dry niche is, all those type of things. I encourage you to read it. Don't skip out on looking at definitions. Okay, they're really important. And as we move through this series, you might see times we'll go back to the code book and look at something if there's a definition that we didn't discuss, so we can kind of make the user aware of it or whoever's watching the video. So we're out of the .2. We're going to move into section 3, which is approval of equipment. So Vince, you want to take us this, since you kind of have a little bit of a background in some of this kind of stuff. So
yeah, so I think we probably should have mentioned earlier, we're in part 1.
We're in part 1.
Part 1 applies generally.
Yep.
Right? So there's a lot of requirements that we're looking at in part 1 here that are going to apply to whether we're dealing with a spa or a hot tub or a fountain or a storable pool or a permanently installed pool.
A lot of them are going to make reference back. Definitely.
Right? And the scope of each part will tell us that, if part 1 applies or not. But for the most, off the top of my head, I think most of the parts say comply with part 1 and
right.
something
So
else.
Part 1 is going to be the
right?
general. So we're
not all of them now, because I think part 7 says stay in part 7.
Yep.
But for the most part,
Pool
part
lifts.
1 is going to apply
is that pool lifts?
generally.
Part 7 pool lifts.
So just be aware of that. We're in part 1, right?
We're in part 1. All right. I'm not going to lose scope. If I start to stray,
I'm going to drag
me back
into the circle.
Okay.
So
there's a lot of different listing groups here.
Right, so I put most of the NRTLs, the nationally recognized testing labs, up there. I think I grabbed that off of OSHA's website. But the approval of equipment in the .3 section here says all electrical equipment and products covered by this article shall be installed in compliance with the article. That makes sense. But they also shall be listed, right? And listed is associated with, and we have a definition in Article 100 that tells us what listed is. But basically, it's going to be looked at by a nationally recognized testing lab, an NRTL. The NRTL process is administered by OSHA, and that information's on OSHA's website. And like I said, I think I screenshot this off of OSHA's website, which has just about all of the nationally recognized testing labs shown.
I think it's also important, though, that people that go into the NEC think that they're going to see a list of all these, and they're not.
No.
OSHA is the one that governs this and sets this up. And the other thing that I point out to people is you might be familiar with one, maybe a large one, but there are other NRTLs. And depending on what products they list, they're acceptable, they're considered equivalent. If they have their listing, if they're able to actually list two things. So in other words, I could have maybe a UL listing on a pump, and I could also have that listing, let's say, from TUV. And if both have the ability to give a listing for that pump under whatever they're listing it for, whatever number listing that they're doing, like for me, I deal in wire and cables, so MC cables, UL 1569, whatever it would be for that pump, whatever it is, they both can equivalently give a listing.
Yeah.
You don't have to prefer one over the other.
It's very common to see multiple listing marks on some equipment. And there's also some NRTL marks here that are shown that we never see on electrical equipment. For example,
IAPMO. It's plumbing.
Right, the second one, second line, the far one to the left, right? IAPMO, like you said, they're the plumbing in the plumbing world of listing plumbing products.
Right.
I doubt you'll ever see that mark on an electrical product. But then we have some of the more popular ones we see in the electrical world.
NSF, very much plumbing driven.
Yeah,
stuff they do.
FM or FM Global, I think. I don't think they're a big player in the electrical world.
Now, they're a big player in the fire alarm world.
Fire alarms, okay.
Yeah, fire alarms, FM's a big player in the fire alarm fire systems. And of course, the other thing is some of the interactive systems that you might have might bring in some type of monitoring system or some type that FM would have a listing for. So again, a big collective group here of them. But again, I think the takeaway here is all the equipment that you're going to utilize has to be listed, okay? And it has to be installed in compliance with the article. And when we all see that in the code, we mean when it says in compliance with the article, it's entirety 680.
Yeah.
So excellent. So, okay. Okay. 680. I'm a big brother, negative big brother intrusiveness here, but there's going to be some point. Vince is going to convince me this is a good thing. Okay. So 680.4 inspections after an installation. So you've got your CO, your pool's installed, it's all done. Inspector leaves, having a good time in your pool, and then a year later, knock, 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 knock. The inspector wants to look and see if there's done anything different to your pool, if your eco-potential bonding grid hasn't changed, anything like that. What do you think? So take it away on dot 4, which again is new, was a lot of debate on how we did this in Code Panel 17. So kind of let's talk about this. And this is going to have to be a program that's put in place by jurisdictions if they want to utilize this or they want to do this.
Yeah, so like you said, this is new, right? This is new for the 2020. The AHJ shall be permitted to require periodic inspection and testing. Shall be permitted. This is not
key.
This is
shall
an allowance,
be permitted.
right? This is an allowance. This is not a shall, must be done, but it's permitted for the AHJ to require this periodic inspection and testing. So again, you're more familiar with conversations, but I assume the AHJ community was driving this one to put some maybe some teeth for them, something that they could hang their hat on, because let's put it this way. I think the reality of it is, and most of us would agree, that in not all, but many, especially in the commercial arena, hotels, motels, maybe some other publicly owned pool areas, that they're not very well maintained.
Now this was driven
right?
to.
Yeah,
this wasn't to try to target the residential
right.
community. This was for the commercial. This was for the hotels, motels. We have, for example, a recently very public death that occurred here in Texas around a motel or hotel swimming pool, and kind of some of the cutting the corners, if you will, and work that was done after it. So it would have been detected on a periodic inspection. But again, that's what it was driven to. Again, of course, this is going to encompass all. So this is nothing that excludes residential, although again, it's not a mandatory rule. It's a permissive rule. So the jurisdiction can choose to enforce it or not. And I think when we met it at the code panel, it really felt originally like it was throwing this down people's throat that they'd have to do it. But it's not. It gives the ability for a jurisdiction to want to be able to do a program like this. Could this be a moneymaker generator and save lives? Absolutely, it could. I mean, I come from this, for example, I was a head of jurisdiction for the city of Alexandria, Virginia, and we do periodic fire alarm inspections and things like that to make sure that the system's up to date and checks. And then, again, we get annual fee, and we come and do that. This could be the same type of thing. And again, don't want it to be portrayed as simply a money generator. In residential, it could come across that way. But in commercial applications, it certainly would not, because, again, they are not maintained as well as they should. The general public's involved in them using these things, and they don't really care. It's not theirs. So they're not as studious to how they do things around it or take care. So, I mean, this does give it, but again, jurisdictions are going to have to be driven to this and create a plan to do this. But they're given the ability to do this.
Yeah, and we had a few fatalities in the state of Florida also over the last few years, and from poor maintenance of the equipment associated with swimming pools, GFCI protection being defeated or negated over time, different luminaires being installed 120 volt luminaires being installed in place of lower voltage luminaires,
Right,
no
right.
GFCI protection being provided. So, and I'm sure that's happened in other places of the country. So the reality, that is the reality. These are not well maintained over time. We know on a brand new installation, initial installation, everything is fine. Looks good, operates fine, meets the code requirements, but over time they are just documented to be poorly maintained. So this gives the AHJs a little bit of teeth if they need it. But like you said, they still have to work it through their local building departments. Maybe there's statutory requirements that they may have to work this through locally, amendments, whatever it is necessary, but at least it gives them something, some avenue to go down the road if they need it.
And of course, we also know we were kind of making light of it, kind of talking about a corrosive environment, but there are deteriorating effects that take place around pools and things like that. So periodic inspections would keep an owner up to date on any type of deterioration or any kind of problem that they can be corrected. And again, it's all, we can joke about corrosive environments or whatever, chlorine being what it is, whether it's even at 10 to 13% chlorinated water, it still can have a deteriorating effect on some components. And at the end of the day, we want people to be able to enjoy their pools and not have the risk of being electrocuted or drowned as a result of something that goes wrong during that installation over time. So again, I'm for it, but I think it needs to be managed as not just a moneymaker and just as a truly intent to be something that errs on the side of safety moving forward. So, and I think jurisdictions will figure that out. 680.5, ground fault circuit interrupters, not to be confused with GFI, not to be confused with GFP, but ground fault circuit interrupters. Tell me a little bit about this again, because I see the ones that are on the screen. I believe they're made by Siemens, so talk about it.
Well, let's first, ground fault circuit interrupter, that's also a defined term. That's defined in Article 100.
Yep.
Right. And this, when you look at the definition, and then there's even a accompanying informational note, I believe, when the term ground fault circuit interrupter is used in the NEC, this is people protection.
Yes.
Right. This is 5 milliamp people protection. You mentioned GFPE, right? Ground fault protection of equipment, which is also defined in 100.
Yeah.
That is exactly what it says it is. It's protection of equipment. It doesn't care about people.
Right.
Set to operate at milliamp levels much higher than GFCI protection.
Yeah, so this 4 milliamps or less, not to activate. 6 milliamps or greater, to activate. We choose 5 as a nominal.
Right.
It's a bench line mark that manufacturers achieve. And so again, but it's designed, if the definition talks about 4 or less, not to activate, and 6 or greater to activate.
So people protection.
People.
This is to
Personnel.
protect us. Exactly. So 680.5 is telling us that GFCI protection can be self-contained, it can be a circuit breaker, it could be a receptacle, or whatever other listed type of protection is out there to provide people 5 milliamp, 4 to 6 milliamp protection. So there's multiple ways to achieve it, to provide this protection, and the code is giving us at least 3, maybe 4, 5, 6, 7, 10 options, whatever other listed types are out there. But I think most popular would be a breaker or a receptacle is what we're going to see.
And also, it's good to remind people that as you move through your electrical career, you're going to remember there are GFCI requirements in 210.8. And you're going to have these requirements in 680.5. You're going to have requirements that are in 210.8, and these are going to be in addition, okay? Unless the coverage in 210.8 also covers and meets the dual application in this, in 680. You could have areas in 210.8, which is dealing with GFCIs, that are going to have its own requirements, and now you get up in 680.5, and throughout the code here when it talks about GFCIs, they're in addition.
Correct.
Addition. So again, don't keep that in mind as you're moving through. Again, makes us remember chapters 1 through 4 apply broadly. Right. 5, 6, and 7 can modify or supplement anything in chapters 1 through 7. Okay?
Right. And that holds true for here for GFCIs. We'll see additional GFCI requirements in 680. We'll see additional bonding requirements in 680 when we talk about equipotential bonding, right? We're going above and beyond what Article 250 talks about.
Get me excited. Talk about 250. All right. 680.7, bonding and equipment grounding terminals. Okay. Vince, take this one away. I know that you, Burndy is a great company, makes a lot of different terminals, terminating devices, and things like that. So what are we talking about here with the 680.7?
Yeah, and this is fairly new. I think this really started about the wet and corrosive environments in the 17, I believe.
And the worry about the termination.
Yeah, and the termination
the validity and the reliability of the termination in these type of environments, corrosive environment, which is another good example of why we did at least need a definition of corrosive environment, because obviously it's popping up in different locations. So
these terminals that we're using for bonding and equipment grounding, they have to be identified for use in wet and corrosive environments. Right? So the code specifically requires that now. Field installed terminals in damp, wet, or corrosive environments, and it tells us they have to be composed of a copper or copper alloy or stainless steel, and all of these are going to have to be listed for direct burial. And they do make products. You know, my time as a AHJ, sometimes I'd hear, you know, well, they don't make that.
Right.
I can't get those. They don't.
That's
make
why I didn't do it,
that,
Mr. Inspector,
right?
because they don't make one.
They don't make it, but and you know, most of the time the reality of it was they do make these products. It's just that the local supply house didn't have them on the shelf because nobody really asked for them. And understandable, you know, if installers don't ask for a specific product, well, there's really no reason for the supply house to keep it on the shelves. But when asked, they will start stocking. So I put an example up there.
I get asked a lot, though. Can you doing the equipotential bonding grid and you're using the 8 gauge running around it, can you use split bolts?
Yes.
Yeah, they're rated for direct burial.
Yeah, I think I may have one.
Might have a slide on that. Might have something that says about that.
So they do. There's just a pick off of the Burndy website, and I'm trying to look at the language. I know I highlighted it, but it specifically says, there we go, that looks a little better. Towards the bottom, UL 467 listed, accepted for direct burial, acceptable for direct burial in earth or the concrete. So they is specifically listed for direct burial.
So when they say they can't find it, I mean, the key thing I think to take away is contact the manufacturers. If you can't get, I mean, all the manufacturers supply their cut sheets for their products that would be able to look up. If you know your installation is going to be a direct burial application and you know what the code is saying about the terminations, then don't try to circumvent the code. If one supply house doesn't have something, go to another supply house. Don't just say, well, I can't get something. Because the manufacturers do make the products. Trust me, as a working with manufacturers, if there's a requirement in this code to do something, you can bet your butt that a manufacturer is going to have a product to meet that need.
Yeah,
I mean, that's
somebody's got it. Right.
That's what we do. We supply products to meet the needs. And so, again, don't just do something because you say you can't find something. Not a good excuse, right?
Yeah, you know, most manufacturers very involved, as you know, in the code process, very involved in discussions, are aware of what's coming and what's going, and are aware that if there's a slot to fill with a product and they can make it, they're going to engage and make it.
Yeah,
that's their business.
Oh well, what are we talking about here? Because it sounds like I was a prognosticator on split bolts.
Yeah, you had your tarot cards out, anticipating the future. So, yeah, since that's a very, very popular product in the pool world for the equipotential bonding purposes, I specifically found that split bolt, again, UL 467 listed for direct burial applications in earth or concrete. So, good to go.
Good to go.
A lot of times on the split bolts, I don't know about one for that'll accept a couple of number 8s. I don't remember if there's enough real estate.
It's
on
not
the
how
top
many
of
you
that.
can get underneath it. It's not how many you can jam in the thing.
No.
Okay.
Well,
no.
we know you could jam probably a lot more than what it's listed for. I was talking about a etched mark on the top of it,
Right.
to signify it actually saying direct burial, because some of these are engraved on there that it is listed for direct burial.
It's a DB. So I'm
Yeah,
DB
sometimes I say
engraved in it.
DB, but the actual listing, the 467 information in the standard, probably allows the marking to be on the packaging
Right,
that
container.
it came in, or maybe the box or the bag.
I
That's
think-
where it'll say
I
it
think
sometimes.
the most that I've seen in this usually have DB stamped on it somewhere, so that makes it a little easier. You know, but the one thing I also noticed in this cut sheet, again, I assume this is also a Burndy. Is it? I'm not sure who it's from.
I may
Is
have
not
cut it
serve
off by
it.
mistake, yeah.
But the thing I'm noticing here is I get a lot of questions that people ask, and you'll notice down here that it says a copper conductor range. And it tells you what, you know, based on whatever the catalog number is, what range of conductors you can utilize in it. But I also notice it says rebar with 1/8 solid conductor. And so it just, it gives you, in the torquing requirements, all of this is provided from the manufacturer. So again, we're trying to meet torquing requirements, 110.14D. We're trying to meet all that type of stuff. And again, the manufacturers are readily going to give you that information. You just have to seek it. So I encourage people, again, and those that listen to my shows know that again, don't guess. Follow what it says, because at the end of the day, we end up in court somewhere, and I'm the person on the other side of the table that's the expert witness, and I can nitpick what you did, and I can determine you didn't follow something in the National Electrical Code as a minimum safety standards. Your issue might not have caused the problem, but guess what? We throw everything against the table, everything against the wall, and whatever sticks, we're going after. So protect yourself. Just do it right. You
Yeah,
don't
I
have to
think
worry
the
about
copper
it.
conductor range, the range of these things, you know, how many conductors or what size can I jam underneath these? The answer is not as many as I can. You know, even if you squish them down with your channel locks or a pair of pliers to get them in there,
Right.
they're listed for a specific amount of conductors and specific size, which shouldn't be exceeded.
Yeah, just some of them will say for two. Our split bowl is for 2 conductors at minimum. You wouldn't need it for 1, but they do make some that are designed for 2 or 3, size dependent. So sometimes you can't, you got to know the size ranges to use them. But again, all this information from the manufacturer. But I think what is great about this slide that you added was that we do get that question a lot about split bolts and things like that. We also get a lot about acorn clamps. And people ask if you can use an acorn clamp to make a connection for rebar to, and again, there are some acorn clamps that are listed for rebar applications. And so again, just check with your manufacturer, whatever you're buying. The counter people at your supply house, again, great people. But again, do your research. All the manufacturers have this stuff available on their cut sheets. And you can get them from anybody. Any manufacturer has stuff. All right, next, 680.8, cord and plug connected equipment. Okay, we were talking about those pumps, cord and plug for the storables and things like that. So walk us through a little bit here what we're talking about, cord and plug. And again, if we need to go to anything and look at the National Electrical Code, you let me know, and we'll jump to it to let our users see it. But again, it should be pretty straightforward.
Yeah, and this used to come up periodically. Again, when I was in AHJ, installers would call and say, can I cord and plug connect? Can I put a cord on the pool pump motor and just plug it in? And
just any random pool pump motor.
Yeah, and the answer is like a lot of code question answers. When you don't get enough information, is
don't say maybe.
Maybe.
Oh, okay.
Or
I have to hear that.
It depends. So what does the code tell us? It says right here in 600.8. I'm sorry, 680.8. Article 600 is for signs, so we don't want to go there. We'll stay in 680 for
a little while. Still there. That's another episode.
Unless we have a sign in a pool.
We could have it in a fountain.
Or a sign in a fountain.
Signs in a fountain. We do have that.
Which we're going to cover in a different part.
Yeah.
But as far as, again, we're in general requirements here. We're still in part one, right? Cord and plug connected equipment. Fixed or stationary equipment. Other than underwater luminaires. So take the underwater luminaires
take them out of the equation.
So fixed or stationary equipment shall be permitted to be connected with, right? Shall be
not required.
Not required, but there is an allowance. Shall be permitted to be connected with a flexible cord and plug to allow the removal or disconnection for maintenance or repair.
Now, the only caveat I add this before you continue is there are some types of equipment that specifically do not allow cords.
Right.
So don't just think you can do this with any piece of equipment. You see a motor that's designed for permanently installed pools, for example, and you end up wanting to say, well, I'm just going to throw a cord on it because I can. Just be careful. Read the listings, read the equipment, look at all the information's there for a reason.
Right.
Okay.
So that the listing or how that product was listed would have to have an allowance for it to be cord and plug connected. Yeah. Some, as part of the listing, may say they have to be permanently connected, period, meaning hardwired,
fixed wire.
And they do not allow a flexible cord to be attached to it. So this is an allowance in the code.
So this is assuming that we're allowed to use a cord and plug, and we're going to have some rules here.
Right. So, and there's the parameters around it. No longer than a 3-foot cord.
Okay.
It's got to have an equipment grounding conductor, number 12 minimum, or size for a table 25122.
So it could be
basically.
larger.
Could be larger.
Can't be smaller.
Cannot be smaller. And that's a very common theme in 680. Equipment grounding conductors normally can't be smaller than a 12, but they could be larger. And also the cord is going to have to terminate in the grounding type attachment plug, and the equipment ground is going to have to be connected to a fixed metal part. So a few parameters there to meet. Got to meet them all, not just 1 or 2 or 3, or it have to be all 3 or 4 maybe. And you can do it. So it is allowable if, for a pump motor, if we're talking about a pump motor, the listing allows it, and you meet the parameters here. If you get a listed pump with a cord on it from the manufacturer, it will be 3-foot max. Right. It will have the number 12.
They know the rules.
Yeah.
They know their rules. They wouldn't put out something, again, they don't want to have the issue of issues. So they have a code, usually have standards teams or development teams or R&D that think about this stuff. And of course, they probably had some input in the development of the certain types of standards.
They certainly did.
I also mentioned, though, we see it says the equipment grounding conductor 12. We don't see it mentioned here copper, but again, it would be copper. Okay, so nobody misconstrues aluminum here. It would be copper in this minimum sizing requirement.
And I think the real question here, the picture I found has the cord on it.
Yeah.
The real question from installers was when they just got a pool pump motor, there was no cord on it.
Right. Just bought the motor. Maybe they're doing a motor replacement.
What can I cord and plug connect it? Again, it's a maybe based on the listing of the motor. And if the listing allows it, then the next step is to meet the requirements in A, B, and C.
Vince, this is why the electricians make the big bucks, right?
I hope they're making big
bucks. I mean, there's so much they have to remember.
Yeah.
It's, it's just, again, I tell people, I'm most proudest of the day I became a journeyman electrician and moved on to the master, and I couldn't think of any other profession I want to be associated with. You have to think about things on a daily basis. You just can't go blindly installing things. And again, electricity tends to always want to work. Even when they do it wrong, it tends to want to work. Creates a safety concern, but it works. So again, for people that say poo-poo on the code, and I hear that a lot, they're saying, people that do and people that teach. And I say, no, that's not correct. The teachers have done it. And now they're wanting to share their knowledge with you so that you're the next generation. You're the people that are coming up that are going to be doing these installations when me and Vince are not here, are gone. And you need to understand it so you can carry this on. So this is a good example of utilizing a listing of a product and understanding what the National Electrical Code says and working together.
Yeah, and I think, both of us came up through the trade.
Yeah. Got the cuts to prove it, still have the scars.
And some of these things that we're going to review in 680 or whether we were in some other article, some of it, not all of them, but some of them we've learned by the School of Hard Knocks because we've installed incorrectly, not knowing what the code required or the nuances of the code, or maybe we had to go somewhere else to get some information about listing, and we got schooled in the field. And by that I mean it was a trip back to the job site.
Money, we only get paid to do it once. Right. We don't get paid to do things twice.
Right. Maybe it was a re-inspection fee. and the trip back to the job site, and time, and new equipment, or a new cord, or replacing a cord and hardwire it. So it comes from that type of schooling also.
And in the worst case, also, we don't want people to get hurt.
Absolutely not.
We want it to be installed safe. And again, these are minimum safety standards. Quickest way to get into the code is to die. Or you go the long route and you have experts and people like you, people out there that work with it every day, and you submit this public inputs and things like that. And we learn there's areas that this is specialized for people. And they have, pool guys, pool electricians, people that do this every day. Just like in PV, we, got Bill Brooks and different people like that are experts in, that's what they do every day, and it's condensed. And so you might be somebody out there who really is connected with swimming pool applications, and you have a lot of knowledge, and we need people like you to submit those public inputs and public comments and things like that in order to make this a better code.
Absolutely. Yeah, I think a lot of installers become, especially now in this day and age, they're nichey. They're very nichey. Yeah. You may have some that are specialized in healthcare facilities, for example.
Right.
And if you took that electrical contractor as a group, or their workers, they may have not have seen or wired a swimming pool ever,
yeah,
or once, and it was 30 years ago, and bring them out of the healthcare facility and put them in front of a bunch of pool equipment, and they'd be lost. But then the same goes. Take the maybe a more installer or contractor who specializes in residential and does a lot of pools, not an issue. But put them in a healthcare facility,
totally
and
lost.
Totally out of the comfort zone. So we lose touch with some articles in our career as we move along, and we focus on others, and that's totally understandable also.
Yeah. 680.9 overhead conductor clearances. Okay, so what are we talking about here? I know we're going to have some images to look at for clearances, but obviously we need definition of clearances for conductors going overhead, over top of areas where the swimming pool is and immediately adjacent areas of swimming pool. So we need to look at this, and of course we're going to have a figure diagram as well that people might be familiar with in the NEC to kind of correlate all this that we're talking about together. But kind of walk us through this.
Right. So we've got some minimum measurements here as far as clearance above the water level. So people may say, well, why do we have to worry about that? Well, a few reasons. Diving boards around pools where you're going to elevate yourself a few feet in the air, most likely above the water. Also think of the pool maintenance people who come in with those.
Oh, the filter, the rods with the screens on it.
And they're telescoping.
Yeah.
For some deeper pools where they can extend that rod 10, 15 feet long, and think of them when that pool comes out of the water.
Yeah, they're out of sight, out of mind. They're not thinking about what's in there.
So we've got some clearances here that the code is concerned about based upon, and they're not all the same. We're going to have different measurements based on what is above us. What are those conductors doing? What voltages are they? So we need to be aware of that and make sure that this clearance is maintained for the life of the pool.
So I noticed in this definition, Vince, it says where the minimum clearance from the water level is given, the measurement shall be taken from the maximum water level. So it again, terminologies and things that we covered previously, what maximum water level is, and so important to understand that when you start to apply these measurements or these distances, things like that.
So the measurements will be taken from the maximum water level, where that water level by definition is going to spill out of the pool. The measurements are not going to be taken from the normal water level, which is normally center line of the skimmer. So, there's at least a few inches of difference there. We're going to measure from maximum water level. That top rail where the water is going to spill out possibly, or the top of the coping, even with the deck.
Right, wherever come out.
Again, wherever that water is going to spill out.
So we have, there's an A, B, and a C to this component. We have the power, and we have communication systems, and we have a network power broadband communication application. So power. Talk us through this here. So.
Power, kind of a
very broad
term
very
here,
broad.
but it says comply with the table, and we have the table of 689A we're going to look at with respect to the overhead conductors or the open overhead wiring.
Okay.
So they make the stipulation there, but whatever is up there power-wise, and I guess power would be whatever is not covered in B and C.
Right.
With default to power.
Yeah, power, anything other, because communication being driven, communication being in things like Chapter 8.
Right.
Communication applications, CATV, power, but then of course we also have network power broadband, which could actually be part of, Chapter 8 as well. So, but we distinguish, I think, power as anything other than network powered. And of course, we only want to bring in the concept in this discussion of power over Ethernet and other types of powers, different voltages, different things that are going to be changing with that. So we'll leave that for maybe 2023 is going to bring all that into it. We'll be able to discuss it later. But power would be anything else other than what would fall under communication and fall under network power broadband.
Right.
So let's go on to this. And so this kind of describes the figure, which we're going to look at here in a second. But it's let's kind of walk around this a little bit, because this is in your code. So hopefully, folks that follow along in your code, what Vince has done here is extracted the information that is given to us in the tables and put this kind of in a tabular format so we can kind of see what we're dealing with, right?
Yeah, it's kind of a reproduction of this 689A table that's in the code book. So, if we work across the top in the petrol green, beautiful Siemens petrol green background that we have on the slide. In the middle, we see voltages. Insulated cables,
right.
0 to 750 volts to ground, supported on a cable together with a solidly grounded bare, messenger, or neutral. To me, that sounds like...
No, that's service drop.
Service drop.
That is what, again, you electricians out there, that is what you're going to probably deal with 99% of the time. Now, you do see that we'll talk about other ones, different thing, but again, that's probably what you're going to deal with most of the time, service drop applications and things like that. But again, what happens, Vince, if it's not insulated cables with 0 to 750 volts to ground supported on or together with a solidly grounded bare, messenger, or neutral?
Yeah, this is very specific, right?
Very specific.
We move over to the right,
which is going to be our what? Our catch it all.
It's a catch-all, right? It says all other conductive voltages to ground, but then does subdivide them from 0 to 15 kV and then over 15 kV all the way up to 50. So the measurements change, right? But I think we're pretty clear that the middle column was, like we said, a service drop.
Yeah.
But what else can be up there, voltage-wise or conductor-wise? Well, we certainly could have overhead conductors from one building to a second building. That's a feeder.
Yeah.
It's a feeder that's up there. Maybe not overly common, but it could happen. So that would be a catch-all. For most residential, even commercial applications, would be the 0 to 15 kV column. Right. So that takes care of the voltages going across the top. And if we work down top to bottom on the far right, we have the clearance in any direction to the water, the edge of the water, the base of the diving platform, or a permanently anchored raft. And I think what we're going to look at on A, B, and C is a little easier to see in a picture.
Yeah, I think the figures are going to tie it all together than what we have across the left side. But it's always important to lead in, because as a student and people that are learning the code, they hear it, and then they visually can tie the two together and kind of get an understanding. So again, I believe that your approach is the right approach. We'll read the left and explain that you're going to have an A, a B, and a C, which is going to come in big when you look at the diagram, because you're going to remember the A measurements, the B measurements, the C measurements all correlate to this information that is here. So again, you want to read over these and then I think it'll be easier for us to understand when we see the figure.
Right, because we got to keep in mind that not all, but in some pools, it's not just the pool that's there. There's handrails associated with pool. There's diving boards associated with the pool. There could be these observation stands that are mentioned in B. Think of a more of a commercial application where if you get into some pool areas, there's multi-level diving boards, and when you get into professional diving or college possibly diving applications,
platforms
where there are different heights, and there's observation stands around these things. So it's not just a
backyard
permanently installed level with the ground pool with a deck around it and we're done. We got to think broader because there are a lot of other pool type structures out there. So that's what the A, B, and C are trying to capture. And C is the horizontal limit of clearance measured from the inside wall of the pool.
So we're going to have height requirements, but we're going to have horizontal requirements. So you think of it, it creates this envelope area or engulfed area of clearance that is going to be both a horizontal measurement and a vertical measurement.
Right. So we work through the table, right? We find our voltage, determine what voltage we're dealing with, whether it's insulated or not, put our finger there, go to the left side of the table, determine if we're in A, B, or C, right? And come down and get the measurement that we need.
I think also we notice that we'll see is that under the more common one, which again, what people worry about with residential. Now, I say common earlier. I mean, residential, you're probably going to be in this area where you're more concerned with the insulated conductors in the messenger scenario. It doesn't mean the other one's not there because, again, we're not talking just residential in this rule. But what's important for people say, well, why do I need to know this? Because you know what? You could be putting a pool in after there's already an existing service drop. So you're thinking, I've got the space, but do you really? Because you have something that might already be existing and you're adding later. Now, very easy on early construction when you're putting it in the ground and the drop's not even there yet. Hopefully you coordinated that with utility. But then you're ahead of the game. But you might be coming in and have a pool company come in. And here's what would suck, is if the line's already there and a pool company comes in, but they hire a secondary electrician to do the wiring. And so the pool company came in and said, you've got plenty of room, sir or madam. Doesn't think about what's above. Puts the pool in, starts it in, and then hires the electrician to come in and do the wiring, gets to the stage where they're doing equipotential bonding grid and doing all that type of stuff, and the electrician gets there and goes, uh-oh. And nobody contingency planned for the fact that that's going to have to move. You're certainly not going to move the pool. Done. But again, your utility might say, I'm sorry, this is our path. Anything that you want to do and go around it or do something else, guess what? You're going to pay for it. Did you factor that into your pool? Did you factor that into the cost? All those type of things, you just have to be aware of it. And again, electricians have to be aware of that getting into it as well. But I also notice at the bottom, it says, extends to the outer edge of the structures listed in A and B, but not less than 10 feet. So we've got some horizontals, but there is going to be a threshold of at least 10 feet. Depending on where the structure is, like a platform or something is. So that's going to come into we'll look at as well.
So if the platform is only 3 or 4 foot, extends 3 or 4 foot, the code is saying, well, that's nice.
It's not less than 10 feet.
But you have to measure out to 10 foot.
Yeah. Right? So, and I think people might not get that if they just stop at A or B or something, and they have to understand how that works. So now this is, again, now I'm going to tie it together and make it a little bit easier for people to be able to visualize, right? And so
hold on, before you go anywhere, I got to say this. Because I created the graphic on the bottom. Okay, that's my artwork, but it's not really artwork. That's me struggling to draw straight lines and whatnot. So before anybody emails
so anybody says that this is not the image that's inside of the NEC?
Yeah, before anybody emails you, Paul, or texts me or emails me, all right, I'll put this out right now. Look at the pool, okay? You see the dotted line that I drew in that to signify the water level, all right? That's incorrect. I should have raised it up just another little bit because the measurement has to be taken from the maximum water level. So I really should have put that line even with the deck, what we call the decking area, where the observation stand starts or the diving board starts. So,
well, in all fairness to you, Vince, I think that we will go to the code.
All right.
And when we look at the code, and we'll scroll down to where we're at, I think you will notice that their water is also not up to the level.
Actually, well, I'm going to give them credit because they're pointing to the top of the wave there. So maybe they think they're signifying the top of the deck and the maximum water level. So, hey, we try to be right on. We try to be, as good as we can and perfect as we can. So hard.
But
perfection.
The beautiful thing is we can observe the code here, and it says, right here, it says where the minimum clearance from the water level is given, okay, the measurement shall be taken from the maximum water level of the specific body of water. So, graphic or not, the code is pretty clear where you take that measurement from. So I save you.
Thank you.
Save your graphic. All right, so there we've got it. And so I think it's, when you're using this figure in the code, it's not brain surgery. You just have to look and see, well, if you're measuring your anything that's going overhead and it meets those columns, then depending on what item it's going over or what it's dealing over, the observation stand or the diving board or the area that's out 10 feet from it, measured up, because it has to be, not less than 10 feet. So.
Yeah, but I always think in the back of my mind, these are always intimidating because there's different voltages, so you have to find the right.
Find the right voltage. So following a step. I'm a big step guy, right? Yeah. So determine your voltage. Again, it's voltage to ground.
Right.
So not voltage phase to phase, voltage to ground.
That's piece one.
Piece one.
Then we got to move to piece two now and work the A, B, or C to determine. And if we're in A and B, it's fairly easy. But if we drift into C and then we get to the 10-foot minimum part, that can be confusing, especially if haven't done the pool in a while. It's you haven't navigated 680 in a while, and it could be intimidating for some, and it's understandable. Because some of the stuff is tough to maneuver through. And
a lot of people think that graphics or images always make things easier. Not all the time. Sometimes you can think you have a good understanding of something, and look at a figure or something and go, "Crap, that's not the way I thought it was," or that's and then you're conflicted here. Right. You're going, "Oh, what?" And it might be somebody looking at it and seeing where it says maximum water line, and then you look at the graphic and it's not necessarily, but they draw the waves, like you said, on purpose because they're trying to capture the top level, and that's the best way they can explain it. So again, just take your time and work through it. The figures are there to try to help. So trying to add a little bit extra to it.
And if you really think about it, we stop for a second, and if you're a user of the code and you've been through the book quite a bit, as far as not tables, there's quite a few tables mixed in the NEC. We have a lot of tables.
Yes, we have a lot of tables.
How many figures are sprinkled throughout the NEC? And I haven't counted them, but it's not a lot.
No, there's not a lot of figures. It seems like they add figures in areas where it needs some additional explanation, but not a whole lot of them, no.
I always think of it, if there's a figure associated with them, because there's so few and far between, whatever the text just tried to tell us, it's too complicated.
So they had to have a figure.
We really need to come up with some type of figure to help out, because we're probably not being as clear as
we're not as direct. So
and I'm thinking of I'd have to flip through it now. I'm thinking of 410. We shouldn't go. Should we drift over to 410 as an example?
You're talking about closets?
Yes.
Oh yeah, you were just there. So what he's talking about is you have in a closet where you can have luminaires, and it gives you a description, and then when you read the description, you're like, what did it just say? And then you go down and you look at the figure, and you're going, oh, okay. The shelf, whether a shelf was there or not, you got to count for a shelf. It still has to be good. Well, I'm not putting a shelf in my closet, so you still have to keep the dimensions as if you were going to put a shelf there, so it can get confusing.
Yeah. So it's closed now. For now, in the 2020, it used to be closet storage space, but it's a closed closet storage space, and it may be the longest sentence in the NEC.
The rambling?
Yeah, it's a one long sentence with a lot of measurements. And again, I think they needed a figure to help that out, and they did put the figure in there, which I think helps. I like them to take all the millimeter stuff out of there, but that's my thing.
And it's ingrained in the code. We always have the millimeter, and the secondary is the actual imperial. So
again, I think for the 680.9a material here, I think the figure is helpful, really helpful to clear up the language a little bit.
And so then we move on to 680.9. Again, we're still in. Well, we were in it still, but now we're going to B. And of course, we're encompassing B and C here as well. So talk to us a little bit about this.
So here's where we break out of, A we just looked at, that was power.
It's power, yes.
So now we get into B, it talks about communication systems, and it's talking about systems that are covered in Chapter 800, Articles 800 through 820. Those are for communications, for radio, for coaxial, right? Mm-hmm. And here it says, just a minimum of 10 foot above the pool, the diving structure, the observation stand, towers, or platforms. So we leave A, we leave 680.9a,
Yep.
We leave the figure behind.
Yeah, no mention in figure.
No mention of the figure.
B or C, no mention.
We just, if it's a communication system, an 800, 810, 820 communication system, the code requirement is 10-foot clearance, period.
Again, the maximum water level.
From the maximum water level.
10 foot.
So it's a much lower height or clearance requirement, and that is because it's a communication system, so the voltage levels we're talking about here are extremely low, probably under 50 volts for most of these. So that takes care of if it's a 800 through 820 system, but if it's an 830 network-powered broadband communication system in parent C, now for this type of system, it kicks us back
into it.
The table and 680.9a.
Okay.
So again, we got to be careful, maneuver through what system do we have, what are we dealing with.
So B is the albatross.
Yes.
A and C, you're going to use this
table. Right.
Okay. Absolutely. Other differences, again, when you're dealing with the network broadband, that's going to be pretty much fixed in 0 to 750. Mm-hmm. It wouldn't have any. Now, the amount of voltage in these with the PO, the power over Ethernets and all this type of stuff that are coming down could dramatically change this for clearances. At what level? Obviously, the code threshold for power probably is going to be, I think in the code it might be, I can't remember, 60 volts or 80 volts or whatever, that they kind of try to create this bridge when it comes to AC powers and things. I just know that power over Ethernet is in deep discussions with people like NEMA and other groups like that, and how that might impact clearances with the power. Is that going to dump it up into the power? Is it in communication? Is it going to be in network powered broadband? We don't really address that here, but at the voltages, I guess it would be under network powered broadband because it's certainly not going to be higher than 750 volts. Certainly not going to be.
The power over Ethernet, I don't really know where it falls. Where does it become power over Ethernet compared to a network powered broadband communication system? Where's the dividing line? Does it turn into power over Ethernet inside the building or inside the
so
house?
that might be premise powered broadband, and again, which is not covered here, but that's obviously once you're already at the demarcation line of the structure, you're already in the building. So probably PoE is probably going to be an internal componentary thing, and that's but what if it leaves from one building to another building?
Yeah, what if it does?
Yeah. So again, we're trying to run more things with PoE. We're trying to run more luminaires and things like that. So as the voltage start creeping up, do we need to incorporate that somewhere in here? So again, welcome to Code Panel 17. We'll appreciate your input on that.
I look forward to the conversations.
680.11, underground wiring locations. Now,
you've been waiting for this one.
No, I will tell people that for years, there was this table that talked about 680.10 which talked about the space perimeters of pools and the type of wiring methods. And I had a bit of inputs in the different types of applications and depth, because I submitted a bunch of public inputs years ago, and they made it in there for the depths of cover for things that are specifically geared with the around swimming pools, right? And so again, with this application, that all went away, as far as the deal with that. And now you just use 300.5 around the swimming pools for the cover and things like this. But when it comes to the wiring methods, there's specific wiring methods that can go around the pool, and there always was very limited in what could go around the pool versus what would be done for anything that would be just like outside of the pool area. Wiring runs around. So this one is very specific to underground wiring within 5 feet horizontal of the inside wall of the pool, and all of the different types of wire methods that we can use. So do you want to go reach those? And I will most certainly chime in where necessary. But again, not to confuse people, this is for the area around the pool and associated with the pool, which would enter into that 5 foot horizontal space.
Right. So
maybe to the pumps, to the luminaires, to all that kind of stuff.
Well, even if it was not for the pool, it could be,
if it comes in that area,
right,
pass through that area, which used to not be that way.
Correct.
Because they didn't want anything that wasn't pool associated to be within the 5 foot.
So this is really any underground wiring within 5 foot from the inside wall of the pool, right? So certainly we're going to have pool wiring,
certainly,
in that area for pumps, like you said, and luminaires. But we could have
a feeder
going
through
out
that
to someone's shed in their backyard, and it just happens to be within a couple of feet of the pool.
Well, what about space restrictions and you have a utility?
Yeah, you could have a service.
So something. Again, the issues with the 5 foot in depth of cover kind of all got melded into something now, and again, you lost that little depth chart, and it's going to refer you now to the typical direct cover that's in 300.5 type thing. So walk us through this a little bit for the wiring methods.
So let's do this first. Let's jump to B. Let's look at parent B. Wiring under the pool, actually literally under the pool, not just. A is going to talk about underground wiring.
Are you saying that I can go under the pool even if I don't have anything that needs to be under the pool?
No, what I'm saying is let's look at B, because that's an easy one. The wiring under the pool shall not be permitted unless it's necessary to supply the pool equipment. So actually going under the pool, literally under the pool, nothing goes underneath there, no wiring, unless it's to supply the pool equipment. That's literally under the pool. But now if we go left to right around the inside walls of the pool, now we can have wiring within 5 foot. But we're going to be limited to the wiring methods that we can use.
Right.
So the underground wiring in A is within 5 foot horizontally from the inside walls of the pool. It's permitted, can do it, but you're going to be limited to the 1, 2, 3, 4, 5, looks like 7 wiring methods that 680 allows.
Question. So the wiring under the pool. So in my design, I have my pump on one side of the pool.
Yep.
And my panels on the other side of the pool. And I'm going to take the which I'll say right now, path of least resistance being the dirt, not reality of grounding and bonding, because electricity takes all available paths, but just for the sake that the electrician doesn't want to run it 30 feet this way and around or this way, he runs it down underneath the pool and comes up on the other side to hit the pump. Okay? It's supplying the pool equipment. Mm-hmm. Many debates on that, where they said not to be underneath it at all. And I think a couple code cycles back, it was kind of in general, there's no wiring under the pool at all.
Right.
And hold me to that. But the misconception with people with that is they were saying, well, does that mean that the equipment is under the pool? No, the equipment doesn't need to be under the pool. It's to get from point A to B to the equipment. It can. Again, if it's associated with the pool, it's probably not how I'd want to do it.
No.
Because I can't get to it later. But
same example. If you couldn't take the feeder and go literally under the pool to get from point A to point
to get the detached structure.
Right.
Can't do that.
Right. That would have to go left to right of the pool, but not directly under it. So
but could go within that 5 feet now.
Could go within the 5 foot, absolutely. This area within 5 foot left to right of the pool, if we draw that 5 foot circumference around the pool, sure, any wiring can be in there.
Well,
if it meets the wiring methods that they allow.
Distinction, because I know there are people out there listening and say, well, what about if I'm going out and I'm running direct burial cable and I'm running that to that detached structure and it's a feeder? You just said the wire method we said the wire method could be within 5 feet. Well, nothing's to say you can't have direct burial cable like a URD or something like that, or in the ground. It's listed. But if it migrates within the 5 feet, you're going to be in one of these wiring methods right here. So how do you make that transition? Okay, you're going to have to make the transition, because at least in the portion around it. So if you have direct burial cable and you're going to be within the 5 feet, do you sleeve it in one of these methods? Nothing says it has to be a complete raceway from point A to point B. So do you sleeve it in that? Does that constitute it? Again, all these things you got to think about. And I don't know we're going to give you all the answers. But here it says that, again, the way the code says, it's going to be one of these wiring methods to be able to do that. So just think about your install a little bit and how you would apply the code here. But again, we have listed methods: RMC, rigid metal conduit, intermediate metal conduit, PVC, Schedule 40, Schedule 80, doesn't matter. People talk about, doesn't it have to be 80? If it's not in the ground, 40 is fine. If you have an area where it's subject to damage and it comes above the ground, then it might be more prudent to be 80 if you're going to deal with that, but not under the ground. 40 is fine. Reinforced, what is that? Reinforced thermal resin conduit?
Yes, I believe that's it, RTRC.
I'm going to tell you what. That stuff is hard as a brick. I used to use that type of stuff when I used to do model rocketry. It saved me money on fuselages. I used to get it in the different sizes. It's because they seem to want to offer a lot for the kits, and I used to use that for that. Dude, you could run that stuff over with a truck.
Actually, a few months ago, I was in the Houston area, and there's a company that makes it just outside of Houston, and I went up there and visited their plant. And it was pretty interesting to see how the product was manufactured. I used it once in my career when I was still up in New York City. We ran it for a service. It was a requirement that the utility required it to be run from their transformers down to the service room, which later got encased in concrete. But the nice thing about it
defeated the purpose there.
It's light. It's very lightweight. The fiberglass type conduit, and it's easy to cut.
Easy,
yeah. So it was easy to work with.
But pretty darn strong stuff.
Very strong, yeah.
And the next one, obviously, is jacketed MC, listed for direct burial. Again, partial to the PVC jacketed MC products, but again, PVC is proven. Obviously, again, when we talk corrosive environment, just to remind you that most of all of the pool equipment is plastic anyway. Incidentally, there is a difference between different types of plastics. There's some that have what's called plasticizer in it that allows flexibility and durability over time, and there is a rigid form of plastic. PVC is typically rigid, and when we're talking about Schedule 80, Schedule 40, can react differently to environments that are corrosive over time. You see it kind of turn white and kind of dry out a bit. It can have a reaction to it. You have less of an impact to a plasticized type of PVC material. It's much more resistant, in my opinion. Others may disagree, because we've exposed it to things like hydrochloric acid vapors for long periods of time, 18 months, under test conditions, and it doesn't affect it at all. So that's an option, although PVC is an option here. Again, their argument is this is underground, so what's the point? It's not going to be exposed really to the corrosive environment, except for Johnny the pool man, who pours all of the chemicals on the floor, on the ground, right near your perimeter, and it soaks into the ground. It is what it is with the pool boy. So then you got liquid type flexible non-metallic conduit and liquid type flexible metallic conduit as well. All of these listed for direct burial applications. And again, the big takeaway is item C. No more confusion on the depth of cover around the pool versus the way it used to be in its own little table.
Right.
I think that went away in 2017 and got rid of it. Kind of bittersweet, because I helped kind of do that table. But now we jump into just normal depth of cover, simplistic.
Yeah, just drop back to 300.5. I think Most people are familiar with that one. So I like that. It's not recreated in 680. We have a table for cover. It's the 300.5 table like we would use everywhere else. So I think that makes it simple.
And a great example of what we keep harping on is chapter 1 through 4, apply broadly, 5, 6, and 7, modify. This is an example where it's sending you back to utilize something in 300.5, which is classic NEC. Rather than regurgitate something, just simply send you back and utilize it, that type of thing.
Yeah, so, we talked about the parts before and all the different parts in 680, and they may point to each other, they may not. There's nothing stopping 680 from sending us back to somewhere else in the code. Absolutely not.
The key thing to remember with that too is it's sending you back in specificity. That's a big word for me. That's sending it back, and it only is pertaining to one part. Okay, that sends you back to the table.
Right.
Okay, so a lot of times things send you back to the code, and you think all of a sudden now does the whole chapter apply? No, just what it's sending you back there. That's what you're applying to the rule. And this is kind of a bit of a capture, if you will, of 300.5, which is the table minimum depth of cover. And so, again, talks about the general location, general applications, but then you have other location applicable things, whether or not it's got concrete or equivalent. We can argue over what's equivalent to concrete, but rocks might be equivalent. In some places, they might consider asphalt equivalent, depending on the jurisdiction. We're all about thickness here. So, and you have other rules for 1 and 2 family as well. So, Vince, you created this as a depiction of it. Anything you want to add onto this?
No, I just did it to take a little bit of a snapshot of 300.5 for those who maybe, weren't familiar with it. But again, this is only a partial snapshot. The full table 300.5 is a little expanded. It's got another row or two, another column or two.
And some notes.
So it does have some notes that have to be complied with too.
Yep.
But I think when we're talking about pools, especially the pool equipment, the piping, or the raceways associated with it, I think throughout the country, the wiring method of choice is PVC.
Probably, yes.
So probably, if we're talking about that, we're probably in the NM raceway column without concrete encasement. As far as depths, probably 18 inches for the most part, unless we hit that 2 inches of concrete or equivalent.
Yeah, the other interesting thing is we have a note that says, okay, well, if you have an NM raceway and you encapsulate it, we do have allowance to have a lesser depth. And so that's the power of a note, which is different than an informational note. Don't get that confused. Information notes, just good information. Notes are enforceable, and they are applicable to the tables that reference those notes, things like that. So,
well, I guess we should note that if you're doing a residential pool, so we got an if there, we may drift into the last column to the far right. We may have a residential branch circuit, 120 volts or less, GFCI protection,
maximum 20
maximum
amp.
20 amp. You may have a branch circuit that's GFCI protected if you're possibly a luminaire, which would allow you to be a little shallower at 12 inches.
And of course, one column we don't see here is also one that deals with signaling and kind of like landscape lighting and things like that, which will also have some depths. Always tend to follow the manufacturer's requirements on those listed components. But again, we do have some allowances for depths as well. So just the moral of the story is you do have depth of cover that you need to be aware of, and always follow the manufacturer's instructions on any type of secondary equipment they might be using, like low voltage lighting or something, pool lighting, things like that.
Ooh, stay tuned for part 2, I guess, because we'll be covering some of that material.
Yes.
Is covered in part 2 for permanently installed pools.
Absolutely. We're going to get in depth.
In depth about the depth requirements.
That's right. Oh, I don't have that queued up. Sorry about that. All right, so next, 680.13, maintenance disconnecting means.
Right.
So, again, talk to us a little bit about this here. So you read it, and then I'll chime in on some an actual experience that I have that installers need to be aware of. But kind of talk about this. So this is our maintenance disconnect requirement that we have here.
Right. So we want to have some way as an installer or a maintainer to be able to turn off power to whatever equipment we're dealing with about the pool, whether that's a pump or a heater or a chlorinator. It could be the pool pump, it could be the spa pump. We want something that we could go there, be able to shut off, put that equipment in an electrically safe work condition.
This is very different than an emergency disconnect, correct?
Absolutely. Emergency disconnect.
I want people to be, wait a minute, is this the... So, and they look at this and they go, is this residential or commercial driven? Everything.
Yeah.
Maintenance disconnect doesn't matter.
Right. Yeah.
Residential, commercial. Whereas the emergency disconnect, it's different.
But emergency disconnect, now we're drifting into a different article, right? 230.85.
Okay. See, so, he's got to rein me back. I'm going ahead of myself. Okay.
Right. So this is a maintenance disconnect specifically for 680 equipment.
Not lighting.
Right. And it tells us, right? It's all utilization equipment. It's other than lighting.
Pumps, filters.
Right. All those things we just mentioned. Heaters, possibly. There's a lot of equipment that can get attached to circulate water, whether it's the pool or the spa. So all the utilization equipment other than the lighting require one or more means to simultaneously disconnect all the ungrounded conductors. Okay, that seems easy enough.
Straightforward.
Then we've got some additional parameters that have to be met, that they have to be readily accessible and within sight from the equipment.
And we all know what within sight, if you Article 100,
right?
Within 50 feet.
Right.
And in sight. Not within 50 feet around the corner. It's in sight and within 50 feet. Definition of within sight.
So you're saying that it could just say, it really could just say readily accessible from the equipment. Because in sight is part of the readily accessible definition.
Okay.
That's a good PI. That's a good PI for somebody out there.
Anybody out there listening, put in your PIs.
We can remove a couple of words, save a little ink.
Code gets cheaper? No. No, it won't. Okay, never mind.
All right, so these maintenance disconnecting means readily accessible and within sight, okay? Located at least, so no less than 5 foot horizontally from the inside walls.
Time out.
Yes.
Readily accessible, able to reach quickly.
Yeah.
I'm fat. So within sight, within 50 feet, don't know that, maybe that doesn't mean it's readily accessible. Is it? Can I get there quick? Yeah, I guess I don't have to climb over anything. I don't have to remove anything. I guess it's still, okay. I'm sorry. I'm trying to create less work for public input, but I'm just saying, okay.
There's no informational note associated with readily accessible mentioning anybody's weight. So.
Wow, okay, good.
So it has to be readily accessible. We got now the 5 foot, at least 5 foot horizontally. This is gonna, so it can't be located any closer than 5 foot. It has to be at least 5 foot from the inside walls of the pool, spa, or hot tub, unless separated from the open water by a permanently installed barrier that provides a 5 foot reach around.
So I'm in a pool. I have a barrier. I need my disconnect, a maintenance disconnect, to be closer than 5 feet as a crow flies.
Right.
But I have the wall there and it's disconnects over here. But if it measures 5 feet in totality to get around the wall to get to it, then I'm okay. Because theory, I couldn't reach it. Incidentally, this language is what we utilized also, the concept of this language is what we utilized in 210.8 when it came to measurements from the sink and the concepts. It kind of took the same concept when they changed that, when they defined the distances that you measure from sinks, the top inside edge of a sink, and all this kind of stuff. Kind of, not obviously word for word, but I mean, the concepts of being able to do that was all kind of together. So I'm sorry.
That's all right. And the last bullet point, you touched on this. The distance is measured from the water's edge. So absolutely from the water's edge along the shortest path required to reach the disconnect.
That's the language. That's the language that we stole.
So, and the 5 foot measurement, 5 foot is mentioned a lot in 680 about minimum distance away from water's edge. A lot of things have to be at least 5 foot away, no less than. So that's kind of important to keep in the back of your mind also.
And we'll have some that'll be 6 feet as well for receptacles.
Receptacles,
so we'll have
6.
all kinds
but
of
5 foot's another common measurement inside 680. Yeah.
A lot of times tied to switches, to switching applications as well. Okay.
And I guess we should go back one.
Okay.
Since I plotted those pictures up there, it makes a general...
And they're all Siemens products, I think, except for the switch.
Except for the switch.
Section, yeah. That might not be the pull-out disconnect. Is that Siemens too? Or is that a Mallard?
No, it's a Siemens.
Oh, that's right. It is. I'm sorry. Sorry about that.
That's why I get paid the big bucks to plot these pictures in there. But so the disconnecting means is a very...
It ain't coming from my budget, folks. I'm just saying right now.
Disconnecting means a broad term. It's not saying a switch. It's not saying a fuse switch. It's not saying a circuit breaker. It's not, right? It's just saying some type of disconnecting
Something
means.
that's simultaneously disconnecting
Right.
all under
It's an
activity.
open and close.
Mm-hmm.
Could
Make
it
or
be
break.
the breaker? Sure, it could be
Sure.
the breaker, but could it be a single pole or two pole switch, toggle type switch? Sure, as long as it's rated appropriately, especially if we're dealing with the motor possibly. It could be any of those things. It's just an open close device to put that piece of equipment in an electrically safe work condition, really, so the installer does not have to work on it energized.
So you could have a pool panel that is within sight, readily accessible, that is 5 feet away, and that would serve as a maintenance disconnect.
Yeah, you're talking about
option.
a sub panel, quote unquote sub
No,
panel, or a
remote distribution panel. We don't talk sub panel here.
yeah, I don't like that term either. But you said pool panel. It could be a intermatic, for example, type
intermatic
pool
control
panel
pool
that
panel.
has a transformer and time clock built into it, but also has maybe some breaker spaces to provide.
Which is what I've
overcome
pretty much
protection.
used when I did the pool.
Sure,
So,
that would all. Those are all.
long
That's
as
a
it-
disconnecting means.
as long as it meets the rules. So excellent. Okay. 680.4.
This is all you,
No.
my friend.
No, because we don't want to have a spirited debate. So 680.14, wiring methods for corrosive environments. And again, now assuming that we understand what a corrosive environment is and the definition was clear as mud for us to understand what a corrosive environment is without any values when it comes to microns or whatever it would be in the air or whatever. Okay. Whatever it would be. I guess you wouldn't have microns. Whatever the concentrations would be, saturation, air saturation, that type of thing. So we're talking about the wiring methods that are going to be utilized in these areas that would constitute a corrosive environment. A lot of work was done into this during the Code Panel 17 period last time for the 2020. In order to craft the language, there's a couple things that I want to say. I'm just going to, again, here's a soapbox moment for me.
Okay.
None of the products that you see here, rigid metal, intermediate metal, PVC, or reinforced conduit, none of those have been evaluated or listed for use in a pool environment. They have a history of being utilized and adequate for a corrosive environment. However, we have seen plenty of rigid metal, intermediate metal rust out. We've seen PVC get brittle. So I was talking about earlier, depending on the chemical concentrations of where it's located. So there's no test for this, but we have historically allowed these type of wiring methods to be utilized in these areas. So when you see the way it's written in 680.14, there's two ways you have to understand this. The first one, wiring methods used shall be listed and identified for use in such areas. Now, it's important to distinguish whether we're talking about pool areas or are we talking about just corrosive environments, because that's the nature of what .14 is of the section. So we want to more broadly look at the actual corrosive area because we know that nothing is listed for pool areas, okay, as a location thing. None of these are tested for that. And I know this because I had to do an extensive research on it, and I could not find any listed for any of these. These are just historically acceptable wiring methods. Over long term. Doesn't mean they're infallible. They're just historically what's been used. So PVC jacketed MC, you might wonder that's not in the list because PVC under 330.12 already establishes that a PVC jacketed, a product that's listed for direct burial, is tested and it is used in corrosive environments. And there is no specific test under UL 1569 that requires MC cable, whether it's standard MC cable or PVC jacketed, to have any type of special test other than the normal testing for that product listing. So traditionally through the industry, we use PVC jacketed with a direct burial MC. to go in the ground, which could arguably could be a corrosive environment. So when I was at the NITMAMS last cycle for 2020, it was argued that any type of method that is outside on the side of a building is subject to rain, is subject to be considered a potentially corrosive environment. But we don't give the parameters for what's considered corrosive or not, other than the fact that acid rain, I'm pretty sure when it rains, it's not distilled water. So there's other things in it. So at the end of the day, you can take PVC jacketed MC, you can put it in the ground. It is listed for direct burial. It is listed for use in those applications that would be more apt to have a corrosive environment. And we do know that the manufacturers of PV material have put out a chemical resistance chart that you can go to, IPEX. And it'll show you that PVC material is very resistant to chemical reaction. And again, the PVC jacketed MC is a plaster-sized, pliable PV. So, a PV material, PVC material. So it is better apt to handle these conditions. And of course, we did a test with it under 18 months of direct exposure to hydrochloric acid, which you can argue is probably the most destructive acid in a vapor environment. Again, chlorinated water is like 10 to 13% chlorine. Okay, so again, it's the exposure it's all about. And I remind you that all the plumbing material is all plastic as well. The pool liners are a plastic material, vinylized plastic. It's all plastic. The containers that hold the chemicals are plastic. So we use a little common sense here. So PVC jacketed MC. But the reason it's broken down into two, the periods, the importance of the period in the actual paragraph in 680.14 is to stop you. As long as it's listed and identified for use in such areas, that would be areas that have proven to be corrosive environments. The reason it goes on to the next paragraph is that it tells you that these that shown here, RMC, IMC, PVC, and RTRC, are to be considered acceptable, not because they had any testing, but simply because historically they were okay in these environments. So again, PVC jacketed MC is listed and identified for use. And it says right in 330.12 that if it is a covering on it that is resistant to corrosive material or corrosive environments, that it's okay. So that's how you get there in 330 for PVC jacket. So people that wonder why it's not listed here, because it doesn't have to be. It's not historically okay because it is listed for use in a corrosive environment. And I'll also just throw in that PVC jacketed MC has been used to motors in those same environments for literally decades, and it's still in use today. So, hey, the shoe fits, wear it. So anyway, all right, enough of that. Go at it. Vince, what do you want to add? Go ahead, knock me down.
No, I'm not. Maybe it's a good time just to highlight the identified part of it. So identified is also defined in Article 100. So we can have products that are listed, and we can use a mechanical lug, for example. Think we're going to terminate a conductor, and we take a lug off the shelf and we look at it, and we may see, and probably will see, a listing mark on it, right?
Right.
But what kind of conductor can you put under the lug? Can you put a copper conductor under the lug? Can you put an aluminum conductor under the lug?
Well, it has to be identified.
It's got to be identified specifically for the type of conductor. So you could get, a listed product, but if it's not identified specifically for maybe the type of atmosphere, in this case, that you're going to put it in, well, so this is very specific.
Great example, MC.
Exactly.
MC cable is a listed product. It's listed UL 1569, but normal MC is not identified for use as a direct burial. It's also not identified for use in a wet location. This is where you PVC jacket it, and now it's identified for a specific use, and it is still a listed product.
Right.
Great
So
example.
It's both. So, this is a little bit more. We saw the requirement earlier, I think it was 680.3, that said all electrical equipment associated with the article has to be listed.
Right.
Okay, that's great. Listing is very important. This is taking it one step further for this application in corrosive environments to say, well, this wiring method not only does it have to be listed, but it has to be listed and identified for use in the corrosive environment, which is in the PVC jacketed MC cables.
So we don't want people to think when it says such areas is specific to pool. It's the area that is corrosive or labeled as corrosive environment. Which you can agree to disagree with the definition of that. That's personal. Here's some examples of areas that would be traditionally, based on the definitions we have now, as a corrosive environment.
Most likely, yeah.
And
definitely.
In places like this, you are going to have accumulation of volume of air in these spaces that are shut off like this with lack of circulation. So again, the only thing I would encourage people, even chlorine, don't get me wrong, you've had your breath taken away from chlorine,
right?
Over chlorine, over saturation. In these areas, again, you see the vents on the side of it. Open it with caution because you could get an inrush of vapors or whatever. So again, it's good. Not a video on that, but things to think about. And of course, this is a great, and I love that and I didn't notice this was in here, but I'm noticing some metal raceways and some wireways and some equipment that is rusting out. So again, I think personally, if all that was PVC coated, it would probably still be okay. But the point is, everybody wants to blindly go into rigid, intermediate, and all those others. I'm pretty sure we've seen some rusted out rigid. I'm seeing some rusted out IMC as well. So again, it's not impervious to it.
Yeah, I mean, this is, I believe, in a larger mechanical room in the city of Boulder. Again, I found this was a little article that I read recently, and they have this picture included. So, this may not specifically be for the pool equipment.
Sure.
And it probably isn't, because I see in the center AH1, which makes me think air handler number 1.
Yeah.
But it is
still a good depiction of some rusted out.
In this environment where there was pool equipment associated with this mechanical room, and there was this atmosphere over time. Right, this didn't happen a week after the installation.
Right.
It happened months and years afterwards that the fumes in the air associated with the pool and pool equipment did deteriorate other equipment in the area. So it happens. We know it happens.
There is a reason that people buy rigid and get a coating on it, PVC coating on it. And then again, that's why I explain to people is use a little common sense, because there's Rob Roy, there's different products that people buy that PVC coated for using it in a corrosive environment.
Right.
So why would you not, consider something like an PVC jacketed MC? Same concept in it anyway. But this is a good example of all that. And again, you see it rusting out. So again, important point with this also is none of those products that are considered acceptable get any additional listing for anything.
Right.
So
well, and this is new material in the code. This first appeared in the 17, I believe. Now it's been tweaked a little bit in the 2020. So 2 code cycles is a very, very brief period of time.
Did y'all see Paul's boo-boo? Sorry about that, folks.
I don't know what you did.
Okay, good. All right.
So, it's new material. We're still kind of navigating our way through it as an industry, and I'm sure there's going to be PIs in for the 2023, and it will continue to evolve and be cleaned up and be improved.
Absolutely. All right. Well, leave it for me to mess my slide up right at the end, man. I was doing so well up to this point. But again, that was a lot of information.
It's a lot of general information, remember, that's going to apply to most of these other parts, as long as the other part in the scope tells us to go to part 1, because we see part 7 and 8 really are not going to push us to part 1. They're going to leave us in either 7 or 8. So again, the importance of the definitions, knowing what we're dealing with in the field, reading the scopes, making sure we land in the right part of 680.
Absolutely. So, all right. So you made it through part 1. You're going to need that information as we move on into the other parts. Most certainly, we're going to need that in part 2, part 3, part 4, and part 5 to some points. And again, part 6. So again, It's good that you have all that base information as we carry on into the next part. So stick with us. Thank you, Vince, for working with us here on the part 1, and we will see all of you in part 2 of this series.